Welcome to room number 2, the better room. Volker, I haven't introduced you yet. You're so impatient and eager. I've actually got rid of them. I'll give a quick reminder of the program for the rest of this room, even though I'm sure all of you have looked at the program already. We have Staying Indoors, OpenStreetMap, Indoor Maps for KDE Itinerary, C++ Coroutines and Qt, KS6, the Architecture Overview, time to slice things up again, and then at 8:40, Wayland for Qt Application Developers, starring me. And then after that, ARM Memory Tagging Extension, fighting memory unsafety with hardware. There is another track, but you don't want that. Track 2 is a place to be. And we'll start talks in 1 minute. I'm just going to make use of this 1 minute as my claim to fame. And that 1 minute is up. I would like to introduce to your stage one of the KDE developers that I look up to. He's a guy I had the pleasure of giving an award to last Real Academy. And as you can see, Volker has decided to not display it anywhere in his room as a way of being proud of it. So, Volker, would you like to unmute yourself as an official introduction?
Okay, thank you, David. Yeah, hello everyone. 3 years ago at Akademy, I showed you KDE Itinerary, our digital travel assistance app. Last year, I talked about how we can use Wikidata and OpenStreetMap in our applications. And this time, we are putting those two things together and going to look at indoor maps in KDE Itinerary. And that is the problem we are dealing with specifically. If you're looking on normal maps at complex buildings, like in this example, this is Berlin Central Station, that consists of 5 relevant floors. 2 of them have railway tracks, 1 of them has bus stops and tram lines, and 3 of them have shops and stuff, right? But if you look at that, it's all meshed together. You don't see any of that. But still, that building is large enough and complex enough that you would want a map to find your way around. So we need something better than that. And I mean, conceptually, that is fairly easy, right? We just split this into different floor levels and display them separately. And that would already get us like 90% there. And we have another important aspect to look at, and that is how you change between floors. That might sound simple at first, but if you think about traveling with heavy luggage or a stroller or with an injury or in a wheelchair, some of the usual ways to change floors, like stairs, are possibly an obstacle that is rather hard to overcome, right? So you want to know exactly what you're going to face in a large and complex building. Unlike with regular outdoor maps, unfortunately, this isn't something that you can just find as a ready-to-use component and integrate in your application. So we have to do the usual thing in that case, build it ourselves. So let's get started. The first thing we need is obviously the data. And OpenStreetMap is the obvious source for that. Luckily, their data model already considers the indoor scenario. And that is mainly done in two forms. There is the level tag that allows us to associate each element in OpenStreetMap with a floor level. And that is a fairly simple thing to do in OSM. And then there's the much more complex set of indoor tags, which allows to model like room level details, walls, doors, pillars, whatever you might find there. That is a lot harder to edit. If we then look at what we find in practice in the OSM data, we notice that the indoor data doesn't have the same global high quality coverage that, for example, the street data has. We'll mainly find that in a number of showcase buildings. And fortunately for us, in a number of countries in a large amount of train stations. So specifically in France, Germany, Austria, and Switzerland, even smaller train stations have a sufficient level of detail. Airports, unfortunately, they are, with a few exceptions, done rather poorly on that, so far at least. But the train stations is at least covering one of our major use cases in Itinerary. So that's good enough to get started. The next step is we need to separate that data by floor levels. That's easy for elements that just exist on a single floor. But then we also have to consider things that connect floors, like stairs and escalators. And that is unfortunately the level of floor level separation where most of the existing proof of concept indoor things based on top of OSM stop. But that doesn't produce what you would expect as a user. So we have to look at a number of additional things there. One such problem, for example, are stairs that have in the middle one or two smaller platforms. Those get assigned like floor 0.5 or 0.3. But that isn't something you want to see in a map, right? Some pseudo floors only containing tiny platforms, that is completely useless. So we need to allocate that to the floor, the actual floor besides those, and stack them in the right order. We have to deal with elevators that cross a large number of floors. We have to collect some information from other sources in OSM, for example, to have the building hull modeled correctly. But that still doesn't solve all the problems. If you remember the Berlin Central Station example from the beginning, that has 5 floors that matter to us, and then there's a bunch of office floors on the top that aren't accessible to normal travelers, so they are completely pointless. Immediately next to that station, there's a number of high-rise buildings that contribute a number of extra floors. We also don't care about those. And underneath, you might find service tunnels or water canals and stuff like that. So all of that we need to filter out. So we end up with a number of rules and heuristics to actually get to the floor level separation that we want. That's an example of incomplete data. This is the main railway station in Brussels. And you might look at that and consider it completely useless. you rather should look at that as an OSM contribution opportunity, because fixing that is surprisingly easy. You just need a few small additions with setting the level tags to turn this from useless to something that we can actually work with. Adding extra text to existing elements in OSM is as easy as it gets in terms of OSM editing, right? So you don't need to measure anything or create any new geometry. That makes it hopefully fairly quick to improve the data quality in the places where we need it. So now that we have covered the data aspect, we need to get things onto the screen. In terms of geometry primitives, this is actually fairly simple. We only have icons, labels, lines, and polygons to consider. Right, so QPainter can handle that out of the box. Label placement is another interesting thing to look at. That requires remembering quite some geometry math. But that is a problem that also all the outdoor map implementations have, so we can just borrow it from there. And there's some fun to be had with numeric stability, as we are working with like centimeter resolution on a global scale. So it's very easy to run out of the out of space in normal data types there. But the real complexity of the rendering is in the hundreds of rules that describe how specific things should look like in terms of fill and stroke patterns, in terms of stacking order, and in terms of level of detail information, so at which zoom level you want to see them or hide them. Doing that in code is possible, but rather annoying. Fortunately, better alternatives that allow us to specify this in a declarative way. One such thing is map CSS, inspired by CSS cascading style sheets from the web. And just unlike there where we match against HTML DOM nodes, here we match against OSM elements. In this example, we are looking for railway tracks. And then, as you know it from CSS, right, we can specify a number of attributes that define the visual appearance, like all the stroke and fill and outline things you might expect there. One interesting thing is how we can specify sizes there. So this can be done in like screen pixels, which means it's a fixed size independent of the zoom level, or it can be in physical dimensions, and that then means physical dimensions in the real world, right? So a railway track in Central Europe would usually be 1.435 meters wide, and then it keeps that width independent of the zoom level. Or as it's done here, we can reference existing tags in the OSM element where that information is already present, right? So we can just access that from the start. And with that, we have an actually quite powerful system to define how things should look like on the map. All of that exists in the very creatively named KOSM indoor map repository as a C++ library that contains all the data processing and rendering code and QML components to integrate that easily in applications. For the data, that uses the same backend server for OSM raw data tiles as Marble as well. That's something I briefly mentioned last year, where we were still working on a new system for that. Meanwhile, that has been deployed. and now has truly worldwide coverage and updates daily from the upstream OSM data. It then might still take a week or two until changes have propagated through all the caching layers. But compared to what we had previously, this gives you very, very quick updates when fixing the data. We have the floor level separation I mentioned implemented in there. We have interfloor navigation, which means if you click on a stair or an escalator, then you jump to the floor that connects to. If you click on an elevator, you can select which floor to go to. The map CSS engine in there is doing everything at runtime, right? There's no pre-compilation, which is very convenient for development. You can just live edit the style shade reload and immediately see your changes on the map. And it is very powerful for applications as well, as you can very easily customize the visual appearance, right? So you can hide stuff that is irrelevant for your use case, or you can highlight things that you're currently working with, or arbitrarily customize that to the user preferences. And then we have built some things on top of that I'm going to show you in a minute. I don't think we have the time for going deeper in the implementation, so I skip that part and instead show you some screenshots. So this is again Berlin Central Station, 3 of the 5 relevant floors. I mean, there's still a whole lot of stuff in there that isn't ideal due to issues in the styling, due to issues in the rendering, and issues in the data. But this is a huge improvement over having everything meshed together, right? You can now clearly see the railway platforms. You can see the stairs and escalators and elevators. You can identify the various shops and restaurants. This is actually useful to find your way around. And it's using the Breeze Dark style, so you will see some of the other screenshots using the light ones. That shows the flexibility in the styling we have. One note about performance. This image was actually an accident. I miscalculated some coordinates and ended up loading the entire city of Hamburg into this. Surprisingly, this loads within a few seconds on the workstation, and while it doesn't really have 60 FPS rendering anymore, it's still somewhat usable. And that just shows that there is more than enough room in there to run this on a building scale on a low-end smartphone. Right, and then let's get to some of the things that we built on top of the mapping data. I already mentioned that we identify escalators and elevators and stairs for interfloor navigation. Another thing that is particularly important for the itinerary use case is identifying airport gates and railway platforms, because that is ultimately where we need to go based on our itinerary. Right? Airport gates are fairly easy to handle. In the real world, they usually manifest as a door. OSM models them as a point. So there isn't much we need to look for or reassemble. Railway platforms are the total opposite. They can be several hundred meters in length and consist of an arbitrarily complex geometry for the platform itself, one or more tracks next to it, which might be split in various subparts. The platform itself might be split in several sections. Depending on country and operators, there's different naming schemes for platforms and tracks. Some of them internal, some of them publicly visible, right? So we want, of course, the publicly visible ones. And for more fun, for historic reasons, OSM has different tagging schemes for that. So data isn't always in a uniform format. So we need to find all those parts and puzzle them together somehow. And the last part is opening hours. So Itinerary knows when you are going to be at a railway station and for how long. And if we know when, like, the ticket shop or the coffee shop are open, right, we can highlight the ones that are open or hide the ones that aren't open while you're there, as there's no point to going searching for coffee and then finding the place closed, right? And here are the pictures for that. On the left-hand side, we see a train connection in Cologne Central Station, I think. So we are arriving on track 6, marked in green. We are departing from track 7, marked in red. And already that bit of highlighting adds value here, right? Because you immediately see that your connecting train departs from the same platform, just on the opposite side. So even if you have a very short connection, that should be easily doable, right? There's no problem with stairs or elevators involved. And that way you can see that. On the right-hand side, we have, or we see different ways on how we make use of the opening hours. So there's this green line here, open for two more hours of the, I think we have the ticket shop selected there. That is a simple human readable description of the current state. For a bigger picture, we have the table view. And as I mentioned, we can also use that to, like, gray out or hide elements on the map. Since that opening hours format of OSM is used in a number of other places as well, the whole code for that is in a separate library, kopening hours. And that contains both the evaluation engine for those expressions, as well as the building blocks for the user interface. That might be something of interest for Plasma browser integration, for example, as websites of shops or restaurants contain that information often in a machine readable way as well that this can consume. Right, and then we have another thing added there, and that is additional data sources that we can integrate into the map. The first one is the operational status of elevators and escalators. That's something we get from Accessibility Cloud, which is a free software service that aggregates that from hundreds of different sources and provides a unified API for that. That's operated by the same people that do wheelmap.org, and they kindly allowed us to use this for this purpose as well. In the screenshot on the left, we see that in action, right? We have 2 escalators that are operational, and we have 3 elevators that are currently operational, all marked in green. And we have 1 elevator that is currently out of service. If you are relying on an elevator to change floor levels, right, that is, of course, a very crucial information. And knowing that building, right, or not knowing that building, you might expect you can just take the elevator next to it. That, however, will get you to different platforms. So depending on where you need to go, you might need use the elevator on the right as an alternative. That is, of course, stuff you need to know somehow, right? And the indoor map provides you with that information. The other real-time data source we integrate is positions of rental bikes and e-scooters. So if you use those to get to and from the station, it's of course good to know where they are placed and if there's some available at all. So here on the right, we see 3 rental bikes currently available at this bike parking space. Yeah, that's the stuff we have implemented so far. And that is basically just the map display, right? This isn't indoor navigation. For navigation, we are missing 2 crucial parts still. One is localization, finding out where you are, and routing, finding out how you get from A to B. Localization is usually done with GPS outdoors, but that hardly ever works indoors. And even if it would, we still have the problem that we need to map altitude in altitude above sea level to floor level somehow. Instead, indoor localization is usually done by measuring the signal strength of Bluetooth and Wi-Fi beacons, and then guessing based on that. That is probably something to look at rather on the Plasma mobile system level rather than on an application level, as that needs somewhat low-level access to the radio devices. And it is something that is very hard to work on while you're stuck at home. That needs some time on site to actually make experiments and measurements. Not so for routing. That is something you could work on comfortably from your desk at home. Routing on the outside usually is done using graph algorithms, right? So we use the streets as a kind of a graph and then apply like shortest path algorithms on that. Massively simplified, but that's the basic idea. With the indoor data, we have the problem that we don't have a complete graph of ways that connect every possible place we want to go. Instead, we also have areas where we just have a polygon describing an area on which you could walk. So we need to kind of mix those 2 data types and build a routing system that can handle those 2. And of course, we need to consider the floor level changes specifically as well. So that's an interesting problem to work on if you like geometry and graph problems. And then there's a few more things to look out for, I think. The thing that actually got this whole work started is I wanted to have the train coach positions properly displayed on the map. If you have a seat reservation in a train, right, that is the information you want to in order to know where you have to go. Now we have the map, and Itinerary also has the coach layout. The problem is bringing those 2 together, as we are missing one crucial piece of information, namely in which direction the train needs to go onto the map. I hope that we'll eventually find a solution for that and then finally get that implemented as well. And that, of course, is also a prerequisite for proper routing, because we, of course, need to know where exactly we should end up in a train station to reach our train, right? Another thing to look into is well, generalizing that and using it for other building types. Right? I have mainly focused on train stations and airports here for obvious reasons. You'll find very good indoor data also in museums, universities, or shopping malls, for example. So there could be value in creating like a standalone indoor map app for Plasma Mobile. We currently have a standalone app that is, but that is purely aimed at developing, so for testing and style sheet changes and so on. We might want to build something proper on top of that. And then finally, there's the relation to Marble. Marble has all the outdoor mapping done already, right? And it has a ton more features than this has. On the other hand, we are missing the indoor mapping there, and there's a few other interesting pieces in here that Marble might benefit from, like the geometry reassembly from the raw data tiles. Marble doesn't do that yet. The map CSS engine, or some of the performance work. So I think we should at least explore how we can, or if there's ways to share more of the work and the code between those two. Yeah, and I think that's it. Thank you for listening. And are there any questions?
So right now we have no questions, but people, please do ask them. I shall ask some questions to Volker so he doesn't have a chance to relax. So you've talked mostly about drawing a map and the actual rendering. Could you talk us through your workflow from a user from going from booking a ticket to using a map? How does it integrate from a Itinerary point of view?
Sure. So we don't have ticket booking integrated at this point. So you book that on the Deutsche Bahn website or whatever. Do you even have trains where you live? I don't know. So assume you booked a ticket on the vendor website. You get an email with a PDF containing that ticket. You're of course using Kmail, so Kmail recognizes that ticket and shows you what's in there in a compact form and offers you to add that to your calendar or the Itinerary app directly. Then in the Itinerary app, you have a timeline that contains your train trip, or possibly multiple train trips, right, if you have connections in between. And for the stations, Itinerary offers you to look at the map. So if you want to know how complex your change is, right? So if you need to change 5 floors, or if it's on the next platform, right? You just open the map there and look at that. There is of course a lot of room there to integrate proper navigation once we have that. But right now it's basically just an option. Open the map at the stations I'm going to travel through. You give me a second, I might be able to demo that.
Oh, live demos. That's brave. We want to see it now.
Yeah, I had that prepared for the map. I just need to look if I have an. Yeah, I have one for Itinerary with demo data that I can show you.
Okay, and if people do have questions, please do ask them. It's your only chance. Volker might be gone from there after this on a big holiday using Itinerary. And we won't be able to find him.
For that, we first need to implement the vaccination certificates as well, but that is ongoing. So let me see if this works. So this is a maybe slightly distorted KDE Itinerary because I tried to scale it up so you have a chance to read it. And the card in here, right, that is the train ticket from Berlin to the PIM meeting in Osnabrück. And just by clicking here, I get the station, the map already pre-selected on the platform I'm departing from. And it even has the arrival platform here. That is not for the not for connecting trip that I booked, but it is for the public transport connection that Itinerary recommended me to get to the station from home. And I can do the same at the arrival location. And there again, it has the right platform already selected. Let me go back to Berlin. That is the slightly more complex station. So here I can, just by clicking on the steps, go down, right, and navigate through the station, or take the elevator back up.
We have one question from the chat, and a question from Pure Tryout is, do you have any plans to integrate with KD Connect? And he's imagining a situation where you can plan a route on your desktop and then do actual navigation on your phone.
We do have integration with KD Connect. I mean, that's how Kmail, for example, sends your train ticket to the phone. So that goes directly via KD Connect as one of the options. What we don't have is that specifically for the for like route planning or anything like that. That is a good idea, Threw. But I think the first thing we would need for that as well is proper routing.
Okay, now one more question. Oh, I've got two more questions. So the first question, how can anyone get this project? How can we run it? And on what platforms?
Oh, yeah, there is. I mean, this is a Kirigami application. Well, Itinerary is a Kirigami application, right? So, and that has this integrated. So that's available on any kind of Linux platforms, and it's available in the F-Droid nightly build and release build repositories of KDE. And we are working on also getting it into Google Play. And that gives me an opportunity to advertise the Android release talk I have on Friday, which deals with exactly how we get this properly deployed on Android.
Okay, one more question's come in, and it is from Hudson. Would gamification fit into your project vision to encourage users to reduce their environmental impact? Environmental impact is, I would certainly see in scope. We have a statistics, I'm not sure if it's, oh no, I don't think I'm presenter anymore. We have a statistics view that shows you like your CO2 emissions based on mode of transport and that kind of stuff. So there is, I mean, I can't from the top of my head come up with a good gamification idea to leverage that. But yeah, I think I would see that definitely in scope. We try to. And you have all your data, so other people could. You have all your data, so other people could then take out those libraries and build something else if they wanted to.
Yeah. I mean, we definitely try to collect the CO2 emissions wherever we have them, and we have estimates based on mode of transport and distance to get it where we don't have them.
Right, I would like everyone to give Volker a big round of applause, obviously virtually, with a clapping emoji or otherwise. And I'm sure Volker will be around all week for questions.
Exactly. So if there's anything else you're interested in, just ping me on chat.
So coming up in 2 minutes, we have Dan Vattil with C++ Coroutines. And in the other room, we have a talk titled The History of Software Distribution, a Personal Journey from Dan Lanier. So 2-minute break if anyone needs to get beverages, cups of tea, popcorn, any other combo. We have 1 minute for your next talk, but Dan can show off his incredibly elaborate presentation setup. Clearly second life as a Twitch streamer. Okay, it's time. So I'd now like to introduce our next guest, Dan Vattil, so everyone give him a big round of applause. Dan's been a maintainer in KDE for ages, working on Akademy, PIM, and all sorts of places throughout the stack. And now he's going to talk to us about C++ coroutines and Qt.
So hello, thank you for the introduction, David. So my name is Daniel. I've been working with C++ and KDE for almost over a decade now. And well, lately I found interest in digging into interesting new features in the C++ language. So that's why I'm here today talking about coroutines and about Qt. Word of warning before I begin. Coroutines are a bit of a complex topic to explain. So there's a lot of things to talk about and not enough time. And also there is a lot of code in this presentation. So you have been warned. I'm not kidding. The first slide already, if I can switch. Yes, I can switch. The first slide already is a piece of code because I think that's the best way how to explain what coroutines actually give us and what they are useful for. So let's get into it. What do we have here? So we have a simple regular function, as you know, it's a member function called getTitle that returns a Q string. What does the function do? Well, it creates a dbus interface so that it can talk to some remote service somewhere else, well, also in your computer, but still it's local, so dbus. Anyway, so we have the interface. Now what we do is we call player.call, so we call some remote function called title in the remote service. Then we just convert the response to QDBus reply because that's how we can extract the response, which is type QString. And then, well, then there's this thing, right? So one thing is we have QDBus reply on one side, and then we have QString on the other. How does the conversion happen? Well, QDBus reply does this magically. But the thing is now, I just said, well, we just did a remote call to a remote service. So we can't possibly have the QString already available, right? It's a dbus, right? That thing does lots of things. So if you do a dbus call here in the player.call, what happens is your applications needs to create a message, send it to the dbus daemon. The dbus daemon must forward it to the actual service that you want to talk to. The service must process the request, calculate the response, send the response back to the daemon. Then the daemon must forward the response back to you. You need to process it, and then finally you might have the Q string that you wanted, right? This all takes time. In most cases, you will just get away with doing this blocking call because what this equal sign does, well, in this case, the operation behind that is when extracting the string from the QDBus reply, it will have to wait, it will have to block the main thread and wait for the response to arrive so that it can extract the Q string and store it in the variable, right? So in most cases, this will work just fine, right? It will take just a split of a second. Users will not notice that you just did a blocking call in your main thread. The application will still seem responsive. except when you are presenting your awesome application in front of a huge crowd of 200 people and your boss is looking at you, and then suddenly you are standing in front of a screen and your application is frozen for 20 seconds because the remote service has crashed or is not responding for some reason. And now your application is doing a blocking call, so it's blocked. It's waiting for the dbus timeout to kick in and return an error instead of title. So you see, doing blocking calls in the main thread is not a good idea. So how can we fix this? Well, one option is we could do player.callWithCallback, which would actually allow us to pass a callback that Qt would eventually call when it receives the response. This is a problem though. The callback, in order to be able, then we would need to change the signature of the getTitle function, right? It would no longer return QString, it would be void, and instead we would have to take some probably another callback from the caller that we would then call with the actual QString that we got from the remote service. But then likely the caller might need to adjust their signature as well to take callback from their caller so that they can propagate the response, right? So this using call with callback or Q dbus pending call watcher, which is a really long name for a really simple class that also does just waiting for a dbus reply. In both those cases, you would need to fundamentally change your API, change your design, and it would propagate to more layers of your application probably. So that's not really cool, right? Just because of this simple dbus call, we don't want to have to re-engineer our entire API. So what are the options? Well, one thing that you could do is you could create a nested Q event loop inside this function and wait for the reply to arrive. Then you stop the event loop and you return. So the signature of the function doesn't change. The function still looks like it's not blocking. It actually doesn't block your UI thread because the event loop will be running nested, but then using nested event loops, that's not a good idea really, right? Don't run nested event loops, especially if you're writing libraries. So what are the options? Well, let's see if coroutines can help. So this is the same function, except it's a coroutine now. Let's see what has changed. So there are three things that have changed from the previous version. First is the return type. The return type now is qcorotask, qstring. Let's not bother ourselves with what qcoro is or what task is. Just think that it's a return type that represents some sort of a asynchronous or pending operation, right? Then we have the co-wait keyword, which is the main thing here. The co-wait keyword, what it does, and then I'll get to that later. And we have co-return as well. We have co-wait and co-return. Co-wait will wait for the reply to arrive. I'll dig into that later. And co-return, that's basically just like return, except for coroutines. The reason we cannot use regular return is because title is QString, but the return type of our function is something else. So that wouldn't match. So in fact, what co-return does is it sort of calls something like task.set return value or something like that and passes it the title. Anyway, look at the co-wait keyword. So in this case, what we do is we do the dbus call like we did before. We convert it to qdbus reply, and then we pass the qdbus reply to the co-wait keyword. Now, what does the co-wait keyword do? The co-wait keyword will trigger a bunch of code that's hidden behind that, partially generated by compiler, partially provided by the coroutine library developer, in this case, me. So what the co-wait keyword, it will look at the qdbus reply and it will say, the qdbus reply is not finished yet. I don't have the result yet. So what it will do is it will suspend the coroutine. Suspending the coroutine means that it will take snapshot of all the local states, so all the local variables and an instruction pointer and some other stuff. It will take the snapshot and save it somewhere in the memory. And then it will return to the caller of this function. So even though the function has not finished yet, it hasn't reached the end, we are already returning to the caller and saving the intermediate state somewhere in the memory. So now let's look at what the caller might look like. You might have a caller that looks like this. It's a simple function called player widget update. And the player widget update, what it does, it calls the remote player getTitle, which should get the title using the coroutines, or it's a coroutine, right? And we know that it's a coroutine, so it might return early, right? We know that it might return early because the dbus response is not ready. But then we want the response here. We want the title. So we need to await again for that coroutine to finish. So we have like two nested coroutines. So what happens when we call remote player get title? It will get suspended. It will return the task, the qcoro task, in some unfinished state. And the co-await keyword here, this co-await keyword, will look at the task and will say, well, the task is not finished, so I will just suspend this coroutine and return to the caller. And then the caller might be as well co-awaiting this coroutine, and so on and so on. They would be chaining up until it reaches a point where either someone blocks and waits until it is finished, or they don't care that it's a coroutine, and it will just continue doing something else. So, and this is important, this fact that it always returns to the caller means that we can have this executed from the event loop, and whenever the coroutine suspends itself, it means that the execution will return back into the event loop. So while the coroutine is suspended, waiting for a network reply or dbus reply, we can have our event loop perfectly looping. Let's look at this diagram. This is state-of-the-art presentation painting. Event loop. Let's say it's Qt event loop. It can be any event loop, but let's assume it's Qt event loop. And this blue bar indicates that the event loop is running, right? It's doing its stuff. It's event looping. And now at some point, for some reason, it decides to call the player widget update function. It could be a timer or any other reason. Simply it calls player widget update. So player widget update starts running, right? And the event loop is blocked. It's not running. That's why it's lighter, right? Here, we can't have both things running at the same time. One function called another function, so the execution is now here. And if you remember, the function update called the get title function, so the execution moves further down here. And then if you remember the function get title, it called dbus call, so that sends some dbus message out and almost immediately returned back. So we are back in get title. Now what's next in get title was the co-await keyword, right? So we are now in the co-await keywords, that's the red box down there, and the co-await keyword looks at the dbus response and it says, well, the response is not ready yet. So I will suspend get title and I will return execution to my caller, which was player widget update. So now the execution is back in player widget update. If you remember, player widget update was co-awaiting on the get title coroutine as well. So here we have the co-await again. The co-await looks at the get title and it says, well, the get title task is not finished yet, so I will suspend myself as well and return to my caller. So now the player widget update is suspended as well, and the execution is back in the event loop. And now the event loop is happily running, processing your events. Your UI is, reacting to user input and so on, while these two functions are suspended. Right? Their state is saved somewhere in the memory. They are not actually being executed. It's the event loop that's running. And now suddenly, let's not go into details how that happens, but let's assume that when the dbus reply arrives finally to your application, it somehow gets triggered from the event loop, goes into some magical dbus handler, and the dbus handler sets the response as finished. And remember, there is a coroutine that is bound to that response. So what happens? The coroutine is awakened. So the coroutine is awakened. We are now in the get title coroutine, which was waiting for the dbus response. The coroutine does something, whatever was after the co-await keyword, so that was assigning it to QString and then co-returning that QString back to its caller. So the next step, it returns the title to its caller, which was player widget update. Player widget update might do some other stuff with that title, set it as a title and some label or whatnot, and then it reaches its end and it finishes. So the execution now, this is weird, it doesn't necessarily return to the event loop because player widget update was called from the event loop. It returns back to get title, and then from get title it returns back to the dbus handler because the dbus handler is the one who actually resumed the coroutine. Right? So the execution after resuming follows from the one who resumed them. Finally, the dbus handler is finished and it returns back to the event loop, and the event loop continues event looping happily. So this is somewhat what happens when you use coroutines, right? When you find a place where you sort of want to wait for some operation asynchronously, but you don't want to rewrite your entire code base to be asynchronous, you can just use co-await. And it's not that simple, but we'll get to that later. Here is the same graph, only if the dbus call was blocking, right? If we did basically the thing that we had in the original snippet, which was waiting in a blocking manner for the response to arrive. If you compare that, when we are waiting in a blocking manner, the event loop is not running at all the whole time, while with coroutines, the event loop is executing most of the time. Those blocks are actually not proportional to the actual execution time. So in reality, it would be mostly dark blue and a very small, the times when the event loop is not running or is blocked would be much smaller than this even. So here you can see that by using coroutines, without actually changing the code, right? We just throw in a few keywords and magically our code does not block the event loop anymore. So now let's look at it. Let's look at coroutines a bit more in general. You may have heard about coroutines before if you use some other languages. Coroutines are common in Python, JavaScript, Kotlin, Go, Rust. They seem all to have coroutines. It almost sounds like C++ is last to the party, but it's not. Anyway, coroutine is a function. It can be suspended at any point and then resumed again from that point where it was suspended. When the coroutine is suspended, the execution returns to its caller, which we just shown. And when a coroutine is resumed, it's resumed as if it was called from the function that has resumed it. We've shown that as well with the weird dbus handler sort of calling the function, right? Suspended function. What's most important for me about coroutines is that coroutines allow you to write asynchronous code in synchronous manner. That means you don't need callback hell. You don't need 15 different signal slots and then lots of connections between them. It allows you to write a code as if it were synchronous, and then you just throw a co-wait keyword here and there, and magically your code doesn't block the event loop, and it's asynchronous. Word of warning though, it does not mean that it will improve your performance. It will not make your application faster. It might help make your application more responsive, but coroutines will not make your application faster. The reason is that not necessarily, of course, but in most cases, the overhead of suspending and resuming coroutines is small, but there is some, right? So if you co-wait for a network request, a network reply here and there, and then you co-wait some dbus request here and there, it's not measurable. The impact is not measurable. But if you would do this in a tight loop, then yeah, there would be a measurable slowdown because of the overhead of suspending and resuming the coroutines. So coroutines in C++. In C++, coroutines were introduced in C++ 20, so in the last version. It's perfectly fine, supported by GCC and MSVC in latest versions. Clang is a bit problematic, so it's in a way it's supported for a long time since Clang 5, but Clang still supports only the technical specification. They still consider their implementation of coroutines to be experimental. So that makes it kind of difficult because if you write your code to be portable to both our compilers, then for GCC everything is in the namespace stud. In the stud namespace, while then in Clang everything is in the stud experimental namespace. So you need to do some magic with macros usually to get it working. The biggest disadvantage is that because it's experimental in Clang, it only works with the LLVM libc++ standard library, right? You can't use Clang and the standard GNU libstdc++ and coroutines. That doesn't fly, right? And this becomes problematic when you try to use coroutines with some distribution provided packages, because Linux distributions usually use the GCC standard library, like the libstdc++, while if you try to use Clang and you build your application with coroutines and with libc++, there might be symbol problems because libc++ and still libc++ are not compatible on the API level. What's interesting is that in C++ 20, the committee, they actually introduced mostly just it was mostly the language extension. They introduced the keywords and described the machinery that's supposed to be hidden behind those keywords. And but what they did is they only specified the bare minimum tools in the standard library that are needed by compiler developers to be able to implement coroutines in compilers. And for library writers who want to write coroutine libraries, right? It's not like there are no ready-made, thing like tasks. For instance, that you see the the task return type. There is no such thing in the standard library that you could just start using immediately as a programmer. The reason is that the idea was that the committee introduced all the tooling that's necessary to write coroutine libraries, and then they led the wider community to actually come up with some implementations so that we can see how coroutines are used in the real world in production, what is the best approach, and then hopefully in the next version of C++ or the version after, there will be some proposals to standardize 1 or 2 different approaches to coroutines, so that after then regular developers can just come, include the coroutines header, and start using coroutines out of the box with the standard library. For now, that's not possible. You need to write lots of the machinery, or you need to write the glue that can be used between user code and the machinery for the machinery of coroutines in the language. So what has been introduced into C++ really? There are 3 new keywords: co-await, co-return, and co-yield. The co_prefix is there to avoid conflict with some other libraries that even before there were official coroutines in C++, there were various implementations using threads and light threads. For instance, in Boost or other libraries, and they have created macros called await and yield, for instance, so that this would clash. So they decided instead to use the co_ prefix to make sure that this doesn't clash with some existing implementations of coroutines in C++. The keywords, what they do: co-await, we already saw. Co-await suspends the coroutine and returns execution to the caller. Co-return allows us to return a value from a coroutine. It's basically like return just for coroutines. And then the interesting thing that I haven't dug very deep into yet, but that's co-yield, which basically allows us to return repeatedly values from a function without the function actually ending, right? Normally, when you return a value from a function, the function ends. But with co-yield, you can actually return the value repeatedly whenever someone asks for it without ending the function. This is useful for writing generators. In the standard library, we have a few things. This is not exhaustive, but there are only like 1 or 2 more things that I didn't mention here. First is the stud coroutine handle, which is a class that is a handle for coroutine, really, as the name says. It allows resuming the coroutine, and internally it holds pointers to where the stack is saved and where the instruction pointer and some other stuff. And then there are suspend never, suspend always helpers, which allow the coroutine to indicate whether it should or should not suspend and when it should or should not suspend. This is customizable, so coroutine, for instance, can decide when it's called, it can decide to immediately suspend itself and then only start executing the user code at the moment that someone starts co-awaiting that coroutine, right? Other coroutines can decide to start immediately executing the user code, and then they run, and well, when someone co-awaits them, they might already get the result. And the suspend never, suspend always allows to control this behavior. So how do you make a coroutine in C++? Well, first you must use one of the keywords co-await or co-yield. If you read the C++ standard, just adding one of those 2 keywords into the code magically makes it coroutine by definition, though it will not compile yet. A coroutine must have a special return type. The special return type, or the return type, is special because it must have a type def called promise_type, which is a type def to some particular class, which must implement some sort of a promise interface. This has nothing to do with stud promise or stud future, right? It's just the naming is similar, the idea is the same. So there must be some promise type. Usually the return type looks something like this task t, where t is the actual type of the value you want to return, so QString or integer. And the way I think about it is the task is like the interface for the caller. That's what the caller of the coroutine sees, while the promise type is what is used internally within the coroutine. The problem is that's what I mentioned initially, is that there is no such return type already defined in the standard library, right? So you need to write it yourself first. And in order to be able to write this return type, you need to understand coroutines a bit more in depth before you can just start using them, which is why it's not so easy to get into coroutines immediately. And of course, you must use co-return instead of return when you have a coroutine. So now, one thing that you might be wondering is, this is back to one of slide 5 or 6. When we had this code, and I said, well, we have the QDBus reply, and then we pass it to co-wait, and co-wait looks at the dbus reply, and it says, well, the dbus reply is not finished. I will suspend the coroutine. And I said, what? Does C++ magically know about Qt? Does C++ understand QDBus reply? No, it's not like that. It's not that easy. There has to be some point, some integration point, right? Someone must have taught how to figure out that QDBus reply is finished or not. And that someone is the coroutine library developer. In this case, the library that I use is, oh, well, I will get to that. But the way it works is basically the co-wait keyword requires an argument which is of a particular type. And the type must either already implement an interface which is called awaitable, or it's like a concept rather. So having a few functions that the co-wait keyword will use to figure out, okay, is it finished yet or not, or should I suspend, and how should I suspend? Or if you remember the promise type from the previous slide, from the return type of the coroutine, if there is a function called await transform overloaded on that promise type for that particular type T, so for instance, in our case, for the QDBus reply, then the co-wait will call this await transform function, and it expects that in return, it will get some sort of an awaitable again, right? So this basically, since the promise type is bound to the return type, it's bound to the return type of the coroutine, so task in this case. This means that if you pick the right return type, so you can provide the await transform overload for any type you want to support. So in this case, I have a little library that provides QCorotask as a class that implements the awaitable interface, and internally it has the promise type defined to some custom class, and this class has await transform overload specified for all different Q types, including QDBus reply. So that's how co-wait learns about QDBus reply, how it is able to determine that whether QDBus reply is finished or not. The library is, surprise, surprise, I call it QCoro, and it's a small library which provides custom awaitable return type for coroutines, that's the QCorotask. This QCorotask has the await transform implementation for various Q types where it makes sense to have some asynchronous some asynchronous operation that makes sense to wait for, and it also provides some wrappers that provide various asynchronous operations for different types as well. I'll explain that in an example. So here, for some types, I call these types like explicitly awaitable. Those are types that they really have only one thing that makes sense to be awaited, which, for instance, we have QFuture here. QFuture really has only one thing that you may want to asynchronously wait for, and that's the QFuture finishing, right? So in this case, what we have here is a Qt concurrent run. Qt concurrent run is basically what it does. It starts this lambda in a thread, immediately returns a QFuture, and then eventually when the thread finishes, the QFuture will be finished and it will provide the result to the caller. When you use QCoro, so if the coroutine returns QCorotask, you can just put co-wait in there, and magically the co-wait will know how to deal with QFuture, and it will be able to wait asynchronously again for the QFuture to finish. And while it's waiting, the coroutine is suspended, and you are possibly running in an event loop. So you can have this nice asynchronous code synchronous-like looking code written in asynchronous way. You don't need to use QFutureWatcher and this kind of stuff. Same goes with QNetwork reply. Really, QNetwork reply has just one thing that you usually want to wait for, and that's the reply being finished. Although QNetwork reply is also a QIO device, which on its own has some interesting things, some interesting asynchronous operations. I'll show that later. So here we create a network access manager we call get, and because again qcoro task has an overload for QNetwork reply pointer, you can just shove co-wait in here, and magically this will suspend your coroutine and asynchronously resume when the reply is finished, and it will return the reply again. Of course, you don't have to always just put co-wait immediately before the operation. What you could do here, you could take the reply pointer, and then you could do some more stuff like query the database, and then do some computation, and then finally, when you reach the point where you really already need the response from the server, that's where you start co-waiting. Right? So you can also use it the way that you fire off an asynchronous request, then you do some processing, and then when you reach a point where you need the data from the response, then you start co-waiting this. So it also allows for some level of parallelism, which is nice. Here is a more complex example with QProcess. QProcess has multiple things that make sense to be co-weighted. It has multiple asynchronous operations. For this case, qcoro has a simple wrapper function called qcoro, where you just put a process, when you pass it to QProcess, and it returns a thin wrapper class called qcoro process. And this class implements part of the interface of QProcess, but it implements it in a way that you can again use co-wait with it. So in this case, you just start some process, and then you asynchronously wait for the process to start. Then you write something in it, and then again you asynchronously wait for the process to finish. So you have a beautiful block of code in a single place that's easier to read, easier to navigate. You don't have to do any mental exercises about jumping through different functions or having nested lambdas and stuff. But just by using coroutines, this allows you to actually to not block your main thread. I think this is the ultimate example that I have. That's also support for QTCP server, QTCP socket, where we have a wrapper for QTCP server where we can co-await new connection. So this will suspend the coroutine until a new connection is available, and then again when the connection comes, it resumes the coroutine, and then again waits until the socket has anything to read, and then ultimately it just reads the data and sends them back with Pong before it. So it's a simple Pong server. The thing is that this has a while loop, right? It's sort of basically an endless while loop, and it seems like there's a lot of blocking. But in fact, you could just put this code into your main thread, and your application would not get blocked, right? Because whenever this needs to wait, the co-wait would just suspend the coroutine and eventually chain up all the way to your event loop, right? This is a list of all the classes that are supported right now. I showed some of them. There is also QTimer support, so you can co-wait the timer to timeout. You can co-await any arbitrary signal emission, and there's general support for QIO device as well. So that's that. That was a quick introduction to coroutines and qcoro. If you are interested more in the qcoro library, there is a GitHub repository, github.com/devratio/qcoro, or you can read the documentation here. Or if you have any questions about coroutines or the library, just hit me an email, Twitter, or Matrix. Thank you.
Let's all give Daniel a big round of applause. I assume everyone's going to be clapping in the chat. So, going through some questions. Jan asks, have you tried debugging and reading the stack traces of coroutines? So if you have a crash, what happens in GDB?
Yes, it's horribly annoying because the support in the tooling is not there yet. So you see random. There is a lot of generated code and generated frames, and these are really hard to debug. Yeah, so debugging crashes are and memory leaks especially. It's annoying. Yeah.
Okay. So annoying is the answer. So the next question, which I think you just touched on at the end, is does this work out of the box for code that is based on signals and slots, like kjob, or do we need to do anything there to make it co-await compatible?
You don't need to modify the classes to make them compatible with coroutines. I did not patch anything in Qt. What you need to do is you need to introduce a wrapper and into the Qcoro library possibly that can handle kjob and then tell the coroutines machinery when to suspend, when to resume. The Qcoro is written in a way that it should be possible to even add support for things like kjob without having to patch Qcoro even. You just need to provide some template specializations and it should work. So I haven't tried yet, but it should work.
That sounds amazing. David is just writing a reply now. So I'll ask one more question. One of the biggest challenges of asynchronous code is managing the lifespan of all the objects that you're going to use in your callbacks and then your Lambda. And all your examples you used earlier, like Python and Dart, they just reference everything. So it's a big problem in C++. How do you resolve this nicely in C++ and Qt?
Well, this is what the coroutines really solve for you, right? Because whenever you suspend the coroutine, the whole stack is saved to memory. So you don't need to, and then it's resumed, everything is restored, and then you use the regular, like, whenever you return from the function, it destroys everything, right? So remember, you suddenly can start allocating many things on stack because you don't have to be worried that your function will finish and then you need to capture everything into Lambda, connect it to some signal or passing it to another function, right? So this actually, I think, makes things not only much easier, but it also allows us to write much safer code because you can allocate everything on stack, so no memory leaks.
For maybe user interfaces where people are closing things. Okay, we've got one more question, and we've got time for it. Ingo asks, is it possible to cancel that update, e.g. if the next title is needed from your original example with dbus?
You can, well, if you have some other code that's executing that would cancel the dbus message, then the message would be, the reply would finish, and it would the coroutine would be resumed, and then you would have to have some error handling. So in a way, yes. Though it's not as straightforward as the code I showed that doesn't really bother with error checking because errors don't happen, right?
Okay. And how does this interact with CPP Coro compatibility or extension?
I haven't tried. The problem is that I found a lot of inspiration in CPP Coro, but the thing is, it depends on the return type, right? So you cannot like mix things from CPP Coro and Qcoro in a single coroutine. So this will become a bit tricky, which is one of the weaknesses, I think, of the current approach to coroutines, that you have to pick one library and then basically stick to it throughout your code base.
Okay, one more question. I do keep coming in. That's how does this relate to standard future and standard promise? I think you touched on this a little bit in your slides.
None at all. None at all.
Yeah.
There is no threading involved, right? You can use threads, but you can co-await a thread, but there is inherently no threading in coroutines.
Cool. And I assume you're around throughout Akademy to answer questions as they come in?
Sure.
Sure. Cool. Okay, the next talk is in 3 minutes. I will pass off to Ivan to be your next session host. So please stay in room 2.
Thank you. Bye.
Unless you want to see a talk in room 1, of course.
Hello, everybody, and welcome to yet another amazing talk at this year's Academy. The next talk will be about KDE Frameworks 6, or the next KDE Frameworks, and it will be given by Dr. Kevin Ottens, the guy who is mean in code reviews and very, very nice in person. So hit it off, Kevin.
Thank you, Ivan. All right, so let's get started with this. Welcome everyone to this talk. So the goal here is to give a rough overview about how KDE Frameworks is structured, and I will cover in particular toward the end an idea which has been discussed during the last KDE Frameworks sprint. And admittedly, that part is more or less food for thought for the upcoming KDE Framework 6 both. All right. First, for those who don't know me, so I started to use KDE as a teenager, basically, so way back in the time. I didn't start contributing right away and waited a few years before doing this. And when I did that, that was love at first sight. I loved the community back then. I still love it nowadays. And so I've been doing things here and there. In particular, I've been stuck quite a bit in KDE libs, and I participated in the setup of the KDE Frameworks architecture. I also do some community stuff, so I helped with facilitating the creation of the KDE manifesto. And nowadays, you might have seen some of my blog posts where I'm using in community data analytics to see how communities are doing, and of course, in particular, KDE or subparts of KDE. Shameless plug, I will have another talk about this with a colleague of mine next Friday. And so nowadays, I'm working at Cloud Couture, where we are doing services around development and mostly tech lead as a service type jobs, architecture jobs, and so on. And I'm living in Toulouse, so in the southwest of France. All right, those who know me, those who attended the training yesterday, they know that I generally start with some history bits. So that's what we are going to do now and go back. All right, apparently it's too loud. I can probably do this, yes. Better now? Good. Assume that's a yes. All right, so let's go with the story. So way back in the time, not right at the beginning, but somewhere in between, we had something that we call the KDE platform, which was basically KDE libs and something named KDE base runtime. The thing at the time was that we had a rather monolithic development model. And because of that, it was not that easy to actually know the dependencies where they went, right? That was a bit ad hoc. So if you took something like Plasma Desktop and looked at the dependencies, it might not be readable for everyone. I think I can actually zoom in, yes, fancy. So you get to see that the Plasma Desktop, for instance, would almost directly link to libk text editor, right? Which would then pull in libk parts straight from Plasma Desktop. Or that you would have WebKit linked in, right? So lots of weird dependencies you wouldn't expect, right? Even things like KDE init, you would have links to kpart and to KIO, right? So that would bring quite a lot just for something rather small as a service. Right, and so libplasma, you would see KIO being linked directly, right? libk file being linked directly. So that's kind of what you get as, I was about to say weird, but that's more surprising dependencies, right? When you have more of a monolithic model. You get dependencies which make sense, and then you get some others which are more opportunistic, right? Well, it's just there in the same repository and we release at the same time, so that's probably fine, right? If I just link to that. That's how you might end up with a big ball of mud at some point. So back in 2010, there's been one of the Plasma meetings, so one which were called Tokamaks. And so during the Tokamak 4, in the snow, there's been discussions around that, right? And where someone basically took an axe and decided to do something about the world problem. That led to that presentation, which was, so that's screenshot of the first slide, named KD Platform Profiles, Low-Fat KD Platform for Your Pleasure. And between the parentheses, if you look, there's the KD5 free, right? No added sugar. So that was even before we considered, going to Qt 5 and coming up with KD frameworks. And already back then, there were discussions about how can we do better regarding the dependencies. And the idea of the platform profiles was to say you could have the desktop profile with everything and all the dependencies, right? And then you could have, if I remember correctly, that was something like a tablet profile. So we would cut at compile time for that form factor some of the dependencies, and then you would lose features. And then for the mobile, we would cut some more dependencies, and then you would lose features, right? So that was kind of a stopgap measure to try to bring less dependencies because you're going to smaller and smaller devices. Obviously, that was kind of influenced by the presence of a famous bootmaker around our community at the time. But that never was really satisfactory, right? The whole, we do it at compile time, so that means it's actually harder to test and validate in QA. And because then your test matrix is just bigger, right? You have to compile with all the different type of flags. And the fact that you would lose features, right? And one of the things is that we want all of our libraries to work well together and provide a very integrated experience when you get them. And there was no way to reclaim that experience, right? If some stuff was installed. So fast tracking more than a year, that's where we had the Platform 11 meeting, which means that was 10 years ago now, right? That was in June 2011 back then. And so we've been looking at more of those graphs. And so, for instance, that the Akademy console dependencies, which was a good one because it tended for various reasons to link to everything. So I looked quite a bit to that one because we could see plenty of the different paths in our dependencies. That was something we did in a cabin in the Swiss Alps, basically. So when you go there, a bunch of kids in a cabin, what could possibly go wrong, right? More prosaically, right, you get a bunch of geeks in the middle of nowhere, so they just spend their time with codes and graphs and looking at stuff, right? So that was actually a very, very productive meeting. We ended up lining up quite a lot of tasks. That picture was taken in that particular cabin at the beginning of the meeting, so you could see that all the tasks, most of all the tasks are on the left-hand side, and I don't remember the number, but that was really huge. And that's pretty much how it looked at the night of the last day, right? So everything is on the right. So a lot of stuff was done there. Most of those tasks were about looking at each libraries and each problematic dependencies we identified in those libraries. So it was a lot of work from quite a few individuals during that meeting. And that's how we came up with the KD Frameworks 5 dependency plan. So there are several things to notice in there. So I know that Volker regret the color palette which is used there, but that's your fault, so you have to live with it now. But one thing you can notice is that we already see, those rows, those columns, right, which says, well, the tiers, right? We get the idea of the tiers already, right? And we get the columns for the different type of frameworks, right? Which is something we still roll with nowadays. There are a few things which are a bit forgotten. So for instance, if you look at K-parts, right, K-parts was meant to be in that particular box, which we call look and feel and consistency. It's not at all how it ended up, right? It has a very different structure. K-part is in tier 3, actually. One thing you might notice, which I think got a bit lost in time, is that we had different shapes for them, right? Because we are looking at either core, either GUI, either widgets, right? Or some stuff which is mixed, right? And we would try to actually separate between the widget stuff and the GUI stuff and the core stuff in different frameworks. We kind of relaxed that when we arrived at the latest model. And so that's the organizational matrix, which is still valid today. So it should look familiar, I think, to almost everyone who's been looking at the documentation of KDE frameworks, because if you look at the API documentation, they're actually sorted, right? You have several tables, one per tier. So you get the tier 1, tier 2, tier 3. And so at least those should look familiar, right? But then we have the types, right? And so we have that solution type, and we have the integration Qt add-ons, and then we have functional Qt add-ons. And if you look, they have dependency rules as well, right? Because we always talk about where something which is in tier 3 can depend on something which is in tier 3, right? Or on something which is in tier 2. Something in tier 2 can depend on tier 1, and something in tier 1 can depend on nothing else than Qt and system libraries. That's basically what we have at the bottom. But then that was actually a bit more complex than that, because if you add a solution in tier 2, well, because it's tier 2, it can depend only on tier 1 stuff, right? But then it could depend only on solution tier 1, or on functional add-on tier 1, or integration add-on tier 1. Now, if I have an integration add-on tier 2, it's supposed to depend only on integration tier 1 or functional tier 1, right? And we kind of lost that in the conversations, right? So I think that's the reason why we kind of lost this, and I'm coming to it in a minute. The reason why it's a bit unfortunate that it got lost is that, in a way, when we had discussions back then, we were thinking that moving a framework in that matrix wasn't only about moving it down, which is then kind of what we've been spending quite some time doing, right? Which is cutting the dependencies at build time and then moving it down in the tiers. But that was also about moving it toward the right, if that makes sense for that particular framework, to move it toward the right, because those are more about the runtime dependencies. So we wanted to get that streamlined as well. So here is my take on why we kind of lost the types along the way. That if you look at the policies that we have around frameworks, that's the description of the type, which I took the extract there. So the constraints from types are the following. Functional Qt add-ons cannot have runtime dependencies. Easy peasy, right? Integration Qt add-ons can have an optional runtime dependency and aim at integrating with the underlying operating system / platform. It's becoming a bit odd, right? Because it can have a runtime dependency or not, right? But then there's an intent. And then you have solutions which have mandatory runtime dependencies because that's part of their design and where their added values come from. Things scalability, resource sharing, resilience, and so on. That sounds complicated, right? I mean, it's complicated because, in particular, you have one where it's a bit mixed up between the presence of runtime dependencies or not, right? Depending on the platform, and then it's mixed between this and the intent, right? It might not have any runtime dependency, but if the intent is integrating in an operating system, then it ends up there. Right? So it's kind of, it feels messy, and for solutions, it's even worse, right? In a way. And so because of that complexity, I think that's why it never quite picked up in conversations. And somehow it was a bit clumsy attempt, right? Trying to draw the line between this about a portable API, which abstracts some platform facility, or is it an API which is more of a building block to make platforms, right? Because we're in that situation where we are both making a platform and we are making applications, right? So that's kind of what we do. We try to do both all the time. And so we're trying to draw that line somehow, right? And never quite managed to do this. So now we kind of catch up with today, right? That the model which is in place with framework. So we see that we have that 2x2, 3x3 matrix. And unfortunately, we use that more like as a single vector, and we kind of lost the rest. In the metainfo.yaml, though, both information appear. So we can do stuff with that. So I went back to some of the old scripts we used to plot the dependencies, and I started to do it again with the 80 frameworks we have today. So what we have there is that each blue dot is actually one of the 80 frameworks, and then we have an arrow between two of them if one depends on the other. So simple as that. For the layout, I forced it so that each layer maps to a tier. Okay, so we have tier 1 at the bottom, and we can see that there are plenty of them where no other frameworks actually depend on them. And then we go one level up tier 2, and then one level up tier 3, which explains why you see some of the horizontal dependencies, right? Because tier 3 can depend between each other. Now, let's try to make this a bit more visual. So red, we got the functional framework now. Green, that the integration, and then blue, that the solution frameworks. Okay. So all RGB. And so we start to actually see them, right? Then the obvious question is, because we lost the types in the conversations, is are we actually respecting the rules we gave to ourselves? Which is that I cannot have, for instance, an integration framework which would depend on a solution framework, right? Or a functional one which depends on a solution one. Which means you need to start coloring the rows as well, right? So you color them by the type of the framework having the dependency, right? And not the dependency itself. So that will be important in a minute. We'll see. Because now if we zoom in, we start to see stuff like this, right? So my green dot there, so that's a zoom from the previous one we had, it's fine, right? We got two solution frameworks, which are depending on an integration framework, right? Because remember, blue, that the solutions, and so we see two blue arrows coming, so they are coming from two solutions toward an integration framework. So for 3x3 matrix, that's fine, right? Then the red dot is okay as well, right? We got one solution and one integration framework depending on a functional framework. We're still fine. And then we got that blue dot. We got so one solution framework depending on the solution framework, right? A blue arrow which arrives on a blue dot, so we're fine. And then we got one functional framework depending on the solution framework. And per the rules we gave ourselves, that's supposed to be forbidden, right? So that arrow here, right, is actually a problem, right? We actually violated one of the rules we gave ourselves for KD Frameworks 5. All right, so definitely something is fishy with the types, right? They're hard to understand. They didn't quite play their role in the maturity system we envisioned, right? Because we never quite pushed frameworks toward the right in that matrix, which I was showing earlier. It's one extra dimension, so that makes more things for people to think about, and that's why they kind of focus on the tiers, because they were easier to understand. And as we see, there are clearly a few mistakes in the metadata, right, that we have due to the above, right? So that asks the question, can we do better than this? So I think the problem we have here is that it's conflating two things, right? It's conflating system abstraction and implementation in our frameworks right now. So if we go back to the original intent of the types, that was to avoid conflating those two in the frameworks, basically. So we provide platform abstraction for portable apps, and so in that way, KD frameworks is an extended Qt. But we also make building blocks for our own platform, right? So Plasma on top of X11 Wayland, on top of some POSIX system, right? That's pretty much what we do, and we do both, and there's a tension between those two. And that tension is not quite resolved, and both are inside the KDE frameworks product, right? And that's kind of unfortunate. So the idea, which was a bit discussed at the last KDE framework sprint, was to maybe say, have a different product, right? And to start saying, well, maybe some of that stuff shouldn't be, in a way, shouldn't be in KDE frameworks, right? That's kind of a different conversation, but at least shouldn't be labeled as KDE frameworks, right? Because the expectation for people is that in KDE frameworks, that's APIs you can use as an extended Qt. And for some of them, it's not quite true, right? If you take K-Wallet, it's not quite true. You're actually linking to a particular implementation of a password store, right? And so there was this idea of saying, well, maybe there's some stuff we should be labeled as the Plasma API, right? Because that's the building blocks for all workspace, for all full operating system, if you wish, which we call Plasma, right? And so I went with, well, looking at the frameworks and saying, okay, which ones are actually in that situation, right? So Baloo is kind of base K activities as well, because K activities have no equivalent on other platforms, right? So it's platform specific due to this. K global access as well, K notify config, K runner, obviously, K wallet, as I mentioned. Plasma framework, very probably, right? And purpose. So the idea behind purpose is actually something which could be portable, right? But what we expose is one particular implementation for those. It's not abstracting you for actions which would work on Android, for instance. And of course, there are more of those libraries which are actually released with Plasma itself, right? But that's out of scope for what I'm looking at right now, right? I'm really focusing on KDE frameworks. So should applications use those APIs? Yeah, sure, why not, right? But they have to know that when they do this, they have a reduced portability, right? And so that if they want to do things well, they need to have if-defs. This is Plasma specific as soon as you touch one of those. And so that's similar to using Windows or Mac OS APIs directly, right? They just happen to be APIs made with Qt, but they are still non-portable APIs. So let's go back to our coloring dots, right, with that in mind now. So let's say that instead of having the functional and integration and solutions, I have only two colors, okay? And so I will have the ones which are not part of the Plasma API, as I defined it on the previous slide, and the ones which are part of the Plasma API, okay? So the red ones are part of the Plasma API. You will notice that none of them are actually tier 1, right? Which is somewhat unsurprising, because that's for our platform where we use our framework, so yeah, that kind of makes sense. And so in that setup, what would be forbidden? What would be forbidden is a non-Plasma API, so something in gray, depending on the Plasma API framework, so something in red, okay? So we have our time to spot that still, and changing the layout actually makes that a bit better. So you might see that there's something fishy going on in that particular area, but there are still too many edges, right? So if we filter out the allowed edges and keep only the wrong one, right? We can see that there's something fishy here, something fishy there, right? And that layout is still not proper. So let's remove completely the ones which have no dependencies left, right? And that gives us the offenders, right? So at that point, we know who is offending. And so there's not many left in there, so it's time to name them. So we have our short list of offenders that way, okay? We know that KIO is dependent on K-wallet, so that's a violation of something non-part of Plasma API, which depends on it. And then we got XML GUI and K-declarative depending on K-global-accel. Now we need to go one level deeper to actually know what inside of those frameworks does those dependencies. And what we find out is that inside of KIO, that's just K-password server, depending on K-wallet. And for K-declarative and K-XML GUI, it's really there depending on the library of K-global-accel, and that's mainly because, well, they have GUI to deal with shortcuts, right? So in the future, what can we do? Well, that we have very good news from that exploration I did, that not too many dependencies to fix. So that's very good news, right? There's basically only 3 right now, which would be out loud if we would go for a Plasma API approach. And we still want to have something finer grained. So that's why I used FD sector for that. Because now we want to get very precise and use a scalpel to cut whatever needs to be cut. So for KIO, K-wallet, this dependency, that's basically K-password server, as I said, which uses just stuff to check a wallet, right? Open it, and then check if a key exists or not, right? That's basically the gist of it. Well, easy solution, right? We're talking about Qt keychain to eventually move inside KD frameworks. Keychain is a platform abstraction, right? So it can talk to K-wallet, it can talk to the tiering on Mac and the equivalent on Windows, right? So just port K-password server to keychain and done, right? So that one is easy. For K-global-accel, so there's a few more which are used, right? So we see that the default shortcut and the shortcut by keys and getting the shortcut for an action and to know if a global shortcut is available, right? All of that is used. We also get things about the shortcut info, right? And the dependencies, so where it gets interesting though is looking at where the dependencies come from, right? So they come from key sequence widget, action collection, shortcut edit widget, shortcuts editor item, and KXML GUI factory. The use cases when you start sorting them by looking at the code in those and how they use the dependencies listed just before is basically setting, getting the global shortcuts, checking conflicts, ending the shortcut settings, and reacting to a global shortcut which changes. We have potential solutions for that. So it already, inside of XML GUI, the work is already done to if-def all of that, right? It already has an have global accel if-def. This is a good starting point, okay? Now the downside to that is that we would have to decide at compile time. So I think what it misses is a strategy similar to what we have for K-message dialog and friends, right? Which is to have some sort of facade to abstract away the uses, and then to have framework integration, right? So that would be our plugin interface, and then framework integration could deliver the plugin like it does already for a few classes inside of frameworks. And so this way we would have cut the dependency, right, while still having all the features if both frameworks are installed plus the framework integration. So in that case, that becomes a deployment question, which is where we want to be at. For K-declarative toward K-global-accel, that mainly comes from similar things inside of K-quick controls private plugins. And same thing, it's because it has something which is called key sequence item, and inside there's a key sequence helper. The only use case there is checking for conflict with global shortcuts, right? That code is pretty much duplicated from XML GUI, by the way. Good news, it's relatively self-contained though. Potential potential solution for that one, it's a very simple thing. Maybe just have a debug call for that one. Right? It's just about checking conflict, right? So just question answer. Debug could do the job in that case. That seems to be a common use case, though. So if we go for that solution instead of the facade in the declarative, we should probably remove the facade. We should probably remove that particular check from the facade on the XML GUI side. All right, what now? So obviously, I mean, if there's agreement on that, then tasks should be added in the KDE Framework 6 workboard. And that would be like one task per unwanted dependency to solve. I didn't go around doing this because, as I said, that's kind of food for thought for the upcoming BOF. So we need to settle on the solutions we want to pick for each of the cases first. And then we just have to implement the task. Again, the good news is that there are not many of them, right? And so then what? Profit, right? Well, not quite. Because what I covered there, that's basically just the technical bits. The real challenge is there after that, in fact. Because then that means that we solved, as I said, with a scalpel, just a few of those, right? But then what happens about that big drift that I'm drawing between frameworks and Plasma API? That's the open question. Do we move the Plasma API frameworks out of KDE frameworks? And that would have community and release management implications, right? Where do they go? Should they be in a separate product, released at the same time than KDE frameworks? My personal opinion is that they should probably be within Plasma because there's value to release them in sync with Plasma releases. I mean, there's a reason, for instance, why we've seen the Wayland server bits move out of frameworks to go in Plasma. It's just a lot of headaches when you have stuff which is released at different times, where you have only one, you already have one primary consumer of them or implementer of them. Obviously, that means that the Plasma team would have to commit to some ABI or ABI guarantees similar to the KDE Frameworks one for those parts of Plasma, right? For the Plasma API frameworks. And of course, that also has marketing implications, right? Because I'm not quite sure how we would communicate about this more widely. And obviously, we don't want to come out with the same message if it's on the KDE Frameworks release cycle, or if it's on the Plasma release cycle, or something else, right? All right, that's everything I had in store for tonight. We still have a few minutes, but not many. If you have any questions, I will try to answer.
So the first question is from David E. When is the relevant BOF?
That should be on Monday morning.
Monday morning, okay. I hope he's satisfied by the answer. As far as
I think that's 9 UTC. If he
then he's not satisfied by the answer. So I just want to applaud the great work and obviously the great talk. All of the questions that popped up during the talk were answered by the following slides, so I kind of deleted them all because they were already answered.
Perfect transitions then.
Yeah, exactly. So this was, I guess, the most professional talk that we had so far. No questions because you answered them all.
Pleased to serve.
Okay, and it seems that nothing else is happening. So thank you again, and everybody give a warm applause to Kevin in the chat.
Thank you.
See you in the following days.
See you around.
Cheers. The next talk will start in 5 minutes, and so you can grab a coffee or something else and get back in 5. So the next talk is a properly brave one. It mentions Wayland, and it's going to be given by a man who needs no introduction because you've been watching his mug for the whole day long in this afternoon session as the session chair. So go on, David.
Thank you. As Evan said, my name is David Edmondson. I've been a KDE dev for over 15 years, Plasma dev for six or seven of them, and I've been a Wayland dev for what seems like forever. So, about this talk, what do I want to do to make it different from all the other talks? When we talk about Wayland, there's always a lot of focus on the window manager or your shells because that's where a lot of the development work needs to happen. But we tend to neglect the applications, which still have quite a lot to do. So for the duration of this talk, we're not going to make any mention of Plasma. We're not going to make any mention of Quinn. There'll be no more mention of any other desktops. I won't mutter the name of any other compositor. Those were good jokes. Don't try to sway me otherwise. And we're going to focus purely on applications and Wayland, of course. So as an application developer, why do you need to care about Wayland? Well, it's one of the biggest transitions we faced as a Linux desktops. It's a lot of changes in a very, very core fundamental area that all of the applications are sharing. So I've got two sets of slides for this, an encouraging one and a more carrot and stick approach. So Wayland does have a load of really cool features that you can use as an application developer. You get far more detailed input events in lots of different nuances that makes the input so much better than what we had on X11, even with Xi2. We have considerably faster rendering. There's a lot less happening to get from you making a change in your application to it arriving on the screen. You get faster frame rates. You can get reduced power consumption. Firefox is doing some incredibly exciting things in the upcoming releases where when a user scrolls, all it does is redraw a scroll bar and then send some magic metadata to your compositor to do all the other work. It can do some very clever things. All around, it's going to be amazing. But if you're a calculator app, if you're writing KCalc, realistically, I'm not going to lie, none of this is going to matter. There's not going to be anything in Wayland that makes your application much better. If it's a boring app, no offense to KCalc, if it's a boring app, it's a boring app. It doesn't really gain a lot. But there is another side to your Wayland side. The more negative way of encouraging people to care about Wayland. You don't have a choice. Or certainly you won't have a choice. Right now, we're not on Wayland by default. And for those that are, they're still at backwards compatibility level of X Wayland, where X clients can still run. But there's a few things to know. X Wayland, which is where a Wayland compositor still supports backwards compatibility, it's not an exact one-to-one match, partly deliberately for security reasons. You still can't just sniff data from other applications. It's not quite the same as being an X application on X. And there's other nuances such as scaling where things behave slightly differently. We're also finding that there's several places where people are switching to Wayland by default, even if we're not in Plasma. GNOME are switching in a lot of places. There are people running Wayland compositors which don't have any X Wayland support. And as people try and phase out X from their systems, at some point, we are going to see desktops where X Wayland isn't an option. So at some point, you're going to have to care. And this is a genuine code snippet from a KDE application. I won't say what. I'm not sure if you can read it, but the code says, if a platform is Wayland, show a message box and quit. And I can understand why I've done that, is to try and encourage people to use X Wayland where right now our performance is better. They might get a better user experience, particularly if this app happens to crash anyway on Wayland. So I can see why you want to encourage users. That makes sense. But this code snippet is also blocking any developer from even trying. And at some point, you're going to find yourselves 5 years down the line, suddenly forced into running on Wayland, and then you'll be surprised when your functionality is missing, and then the users are going to be forced into a bad situation. It's important that we start early, and all the developers should be doing things on Wayland and at least reporting and elevating any issues they have and making a big fuss if something is missing. So when it comes to this code, I'm not angry, but I am disappointed. So what's the current state of a Qt application if you run it on Wayland? Because in theory, Qt abstracts everything, so it should just work, just like Qt on Windows. Right? Well, the difference between theory and practice is in theory, they're both the same thing. In practice, there are some nuances. And that Qt example is quite good. In theory, it should work, but if you look through the Qt repo, you can see it's Christoph Coleman making a bunch of changes which are Windows specific because things were found, even though the KDE libraries and the Qt framework should have abstracted it. It's also interesting to note it's the Qt developers making those changes. Steve Ballmer's not making those changes. Microsoft's not doing the work. He's sitting about in a massive mansion. And that's true for your Wayland port. It's very similar to porting to Windows. It's a whole new platform. And you can't expect all your Wayland developers to do your work. I'll be lounging about in a massive mansion. So, let's say you try your app on Wayland and there's a bug. Who's at fault? There's actually a couple of different answers because there's lots of components in play. There are deliberate Wayland behavioral differences where we're not trying to make things behave exactly as they are on X, and it will require applications to adjust. There are also, potentially, you've got bugs in your application. Just because something happened to work on X11 and we should be abstracting it, we might be surfacing some bugs that already exist. We also have a completely new plugin part that we're going through in Qt. It's a very different code path. So we might find we're hitting some bugs in Qt Wayland, and Qt Wayland is a lot of code, and it may have bugs in it. There could be bugs in the compositor. And generally, this is the first place to get blame, but for most things that are happening inside a typical standard Qt application, it's not where a bug is going to be. It might be, but it shouldn't be your only point of complaint. You might also find we're missing specifications. Wayland is behaviorally different from X11. Some things behave differently, and often something that could have been done in X through a hack, we're trying to do in neat, very semantic ways in Wayland. But because of that, we need to come up with a new semantic way for each of these individual use cases. So you may find there's specifications missing. And then we have to go all the way up to upstream because it's important that we get things standardized so that even when we fix our application, it doesn't just work on KDE, but it also works on these other desktops. So let's go over some of the deliberate Wayland behavioral differences. And I'm sure you may have heard all of these already. You cannot make a libx11 call as a Wayland client. This probably goes without saying, but it does happen. We see code paths where we hit it. It's one of the easiest things to search for. If you're doing something with X11 or QX11X's display or connection, it's obviously going to fail. In general, most cases where we hit that, we have found that an abstraction layer has already been written in frameworks. I'm not going to say that's true for everything you could possibly do, but in general, we're trying in KDE to introduce these abstraction layers. And obviously Qt is an abstraction layer. Another big behavioral difference is you can't eavesdrop events. Wayland clients only get input when they have focus. So if you don't have focus and you want to find out when a user clicks a mouse or presses Shift-X-Q, you can't. You don't have those events. And this is important to mention, this also happens if you're running inside X-Wayland. So if you're doing your own by-hand idle detection or your own by-hand global shortcuts, it's not going to work by design. But if you use abstraction layers, kidletime and kglobal, it'll just work out the box. It'll just continue to work exactly as before, which is amazing. You can't grab other window content, and this is deliberate. If you call QWindow grab window, it will just return an empty image. The best thing to do is replace it with a dbus request to XGG desktop portal. And this is true if you want to find out the color of an individual pixel for like one of those color drop icons. One thing we're seeing in Wayland is not everything that was done in X11 has a direct equivalent in Wayland. There is a direct equivalent, but it's not necessarily just because it's in X11, which happened to be the display communication. We don't have to do it in the display communication when reporting to Wayland. Sometimes we're doing things using other technology and other things out of bounds. And if you want video content, I forgot to mention this, if you want video content, you want to use Pipewire. And there's code in Plasma doing that already. One of the bigger changes that probably is more likely to affect you for a common app, global positioning. Wayland windows don't know where they are, and they can't set where they are using the main shells that we have. And this is probably one of the biggest porting challenges, but there are a couple of options that are available and supported. The most important one is a framework called XGG Positioner, which is where we semantically state where a pop-up should be relative to your parent window. So you would have this if you have a window and you want to open a context menu or a little tooltip or a combo box where you get a drop-down list of options. All of those are new windows, and we're saying where that window pop-up should open relative to your window that we already have. Now, one challenge with that, one behavioral difference, is if you open something without global positions, the client can't do detection of whether we're going to hit a screen edge or not. So if you have a combo box with a really long list and your window is quite near the bottom of the screen and its combo box is near the bottom of the screen, you don't want it to overflow off the screen because that's rubbish. And on X11, you would typically do some of that code yourself, or sometimes the window manager will just shove it on top of your combo box. It would just shove it randomly. But with XGG Positioner, which is really quite clever, you can provide hints on how to handle a constrained situation. So in this example of this combo box that doesn't fit beneath, you can say, well, I want the contents to be above where my combo box is and not just occlude it. Or you could even say, I want everything to be shifted to your right, to avoiding a combo box this way, or to resize a window. And you can tell it how you would like it to be handled, and then the compositor does the right thing. So it's a very, very well-designed class, but the Qt implementation is kind of weak. You're using this framework implicitly whenever you create a Q menu, Q context box, or Q combo box, or a little tooltip. But what Qt is doing internally to match existing internal API is just mapping everything to a global coordinate and then mapping everything back into a relative position. And then we're not exposing all of these clever APIs that exist in the framework. One of the other protocols that exists is Plasma Shell, which is what we're using for all of the panels and some other custom parts within Plasma. And here is a sneaky sort of add-on API that we've added specifically for panels and things, where you can set an exact position in global coordinates. And if you look at the code for Plasma panels, you'll see this. And the downside of this is it's not universally supported. In fact, we're even trying to restrict the access within KDE applications. The implementation was done quite early on in our Wayland development, and in hindsight, it's quite poor, particularly with our changes, and overall, we're trying to phase it out. But you might see this class listed. And last but not least, one of the new things that are popping up in the scene, Layer Shell, which is where we semantically position something on a screen. So if you're familiar with QML anchors, this is basically the same, but for whole windows. We can say, I want my window to be anchored to your right, and I want to be anchored to your left, and the top, and 200 pixels tall, and it'll be a top 200 pixels tall. And you've got margins and such, exactly like QML anchors. And we've used this already inside Ksplash, and we've made an entire library available where we expose every feature that's relevant inside Layer Shell, all of his margins and different offsets. And this is a somewhat standardized protocol. It works outside KDE. One big con with the current implementation that will be fixed out, it's just a technical hitch temporarily, is you can't have Layer Shell and regular windows in the same application. Once you've committed to using that Layer Shell library, you then have to use that Layer Shell library for every other window, which means every other window needs to be semantically positioned to a screen, which doesn't make sense for some situations. So what are some of the other differences we see in Wayland? It's quite strict in terms of protocol on what it can do. One thing, just to enforce that your application is doing things correctly. So pop-ups are one example. So for every time you have a pop-up, you must have a parent. And if you have a pop-up that creates a pop-up, you must do this in the right order. You must create a pop-up that depends on a pop-up after your first pop-up, which seems natural. But it's also important from a Wayland protocol perspective to destroy things in the correct order. You can't open a pop-up and then a pop-up from it and then close the original. Doing so is Wayland considers illegal. It's akin to murder. It's one of the 10 commandments: don't murder, don't create, destroy your pop-ups in the wrong order. And Qt Wayland tries to hide these problems, but it's having to sort of retroactively guess what your client should be doing. So anything that is moderately sane is supported inside the Wayland protocol. But if you've got something very quirky inside your code, it can just cause everything to just be closed, or your pop-ups to be closed in the wrong place. So here's an example of what I mean with multiple pop-ups. In this case, it's important that we close this rightmost pop-up first, and then the middle one, and then the left one. If you do anything wrong, initially your application will be terminated, but Qt Wayland tries to solve that. But if it tries to solve it, you'll just get a situation which just doesn't work, which is slightly better than crashing, but not by much. Window activation. So what do I mean by window activation? That's where we're passing focus from one window to another. So I'm in my chat application, I click on a link and open a browser. I expect a browser to suddenly appear in the foreground, even if the browser is already open with some other content inside. Or you're in Dolphin, you've got your spreadsheet, you've got your list of files, you click on a PDF of this presentation, you expect your PDF viewer to come to your front, even if your PDF viewer is active. Or the storing from the system tray, where you click on the status notifiers, and for Telegram, you want Telegram to appear. Makes sense? So I'm going to do a quick reminder of how this should be done on X11 and what you should be doing right now. So you should be creating this magical string, either getting your user time or using case startup info. And then we pass this out of bounds over the dbus message that we're sending anyway, or over an environment variable if we're creating a new process. And then the receiving client should import this and then use QX11 extras, set user input time, or use case startup info to import this magical token, which does everything internally. And only then do we call request activate. So that's what you should be doing now. What everybody probably does is ignore all of this and just call force active window. And it's something that if you heard Martin complaining about focus issues on Quinn, you would be told not to do this. API documentation says not to do this. Pragmatically, lots of people do, because it worked and it was simpler. So now let's talk about what you should be doing on Wayland. Well, you should be creating a magic token. You should be passing out using any other methods, dbus environment variables, and then importing that into a new client. So the concept is exactly the same as what you should be doing, but we don't have a force active window lazy workaround. The API is subtly different, and I would go as far as to say it's considerably easier because case startup info is very, 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 very confusing. So new classes are kwindow system request deactivation token, and then you get a signal back once it's, because it's an asynchronous operation. And then from a client, you import it and you call set current deactivation token on a window, and the window goes into foreground. And where possible, we are trying to handle this implicitly into existing calls, like case startup info on X11 when you launch an application. But when you're importing a client, when you've been activated, we tend to be in the client custom code, so a client does need to adapt. Okay, so minimizing to a system tray. If you use QSystem tray or KStatus notify item, everything will continue to work as is, particularly on Plasma for QSystem tray. One behavioral difference I'm seeing quite a lot, particularly on random Qt GitHub projects, is you don't have API to know when a window is minimized. So if you've got this fake concept of you click close and it minimizes to your tray, it simply isn't going to work. Okay, so that's some very deliberate changes you need to be aware of. But I'm going to talk about some bugs in your app that Wayland might be surfacing. There's one common one that I've seen 9 times that I'm going to go into detail of. Right, so if everyone remembers Qt 2, Qt 3, very early days of X11, every widget used to be its own independent window. So a button was a window, a label was a window at a very technical level. And then all of these windows formed together to create a top level window as you would know it. Right? And in Qt 4, I don't know exactly when, at Qt 4, we stopped doing that. Now we just have a window that has all of the window content. But this code path was kept. You could still turn a widget into a window because it does make sense deliberately in a few very, very specialist cases. So if you're a media player, putting in media content in its own separate window, OBS does this, it makes sense. You can get some performance boost out of it in some specific cases. And Wayland has an analogous situation to this X11 window embedding for these same specific cases. There's a concept of Wayland subsurfaces that Qt abstracts. So in theory, this should all work exactly the same. There's no need to be aware of it. And that is true for any correct code. But one problem we've been seeing a lot is it's very, very, very easy to accidentally turn a Qt widget into a window when you're not trying to do it, when you're not doing it for performance reasons. And if you turn something into a window and then never show that window, never call Qt window show on that widget, you end up in a situation where you created a window but then rendered the content somewhere else. And doing so accidentally causes no visible issues on Qt on X11. It's still buggy, it's still wrong, it's still very, very weird, but you can't see those. And I can't expect developers to fix bugs that you can't see. But when you're running against Qt Wayland, very, very bizarre things happen because it just can't map things quite correctly. So you get situations where your input just doesn't reach certain widgets. So it has this slightly odd effects that you need to be wary of. So if you have do encounter this bug, where your symptoms are things are just behaving weird in this subtree of widgets, check for this. And it's quite easy to check for, just put a breakpoint in the Qt platform window constructor. You should only have the Qt platform window constructor when you're actually creating a window. Similarly, the same bug, but coming up in a different way. Avoid QGL widget. It's a class that you don't want to be using. It's rubbish. Qt OpenGL widget should be used instead. This is what the documentation inside Qt says. Follow your documentation. But we have seen people where people haven't made it. Have seen cases where people haven't made a port yet. Another related case, if you are deliberately turning some widgets into a window or deliberately using subsurfaces, be sure to enable this flag, which I've cleverly cut off, called Don't Create Native Widget Siblings. And without going into what this flag does, is it breaks your application and you don't want it. It's there purely for some compatibility with if you want this very same behavior as what we had in Qt 2 and Qt 3, which you don't. And there have been some other situations. I fixed a crash in Kio where it just expected input to come in a certain order after we create a modal dialog. It was sure that once you created a modal dialog, any input must be in that modal dialog. Anything else would be something to assert over. And that wasn't true on Wayland because there's a slight asynchronous gap. And there are many, many cases where things happen to work fine on X11, but it doesn't mean your app was right. Not seeing a bug doesn't mean a bug wasn't there. And the takeaway from this is you just need to test. So let's dive a bit into Qt Wayland itself. Qt Wayland somewhat has an impossible job, because in Wayland, people are trying to revisit how can we do window management and all of the display server works in some new and creative ways. And those ways aren't wrong, they're just sometimes new and different. And Qt has to have backwards compatibility and forwards compatibility. Qt Wayland has an API that is fixed and abstracted, and we had to support absolute 10 years ago. We have Qt 6 API frozen, so we're frozen for 6 years into the future. And Qt Wayland is stuck in the middle, trying to bridge these somewhat times different concepts. So it's in a difficult situation, but despite that, it's quite good. The code is really well written, the unit tests are excellent. Another challenge with Qt Wayland, and an opportunity, is Qt Wayland is Wayland itself lets you cherry pick what you want to support. If I'm making a coffee machine, I don't necessarily need drag and drop. So your compositor just wouldn't implement it. And we see this quite a bit. The Qt Wayland has effectively two distinct sets of user groups, with the desktop side and the embedded side. And inside Qt Wayland, we're seeing divergent code paths, because you can completely replace one of the core protocols of how you turn some window content into what the window manager considers a window. So if you're only showing a full screen window, you don't need the concepts of resizing and all of these. So you go through a completely different code path with an API that matches what you need. But the problem there is Qt Wayland then has these divergent paths. KDE has been very active on Qt Wayland. We've made well over 50 commits, and I think the Qt Wayland people do a very good job of now asking us for our opinion on any patches that would affect us. 2 developers have gained approver status because of the work we've been doing in Qt Wayland. That's myself and Alish. So if you do work on Qt Wayland, you are going to be met with friendly faces, or my face, when you make that patch. And to some extent, we're seeing a slight change in the Qt company's core demographic of not being so much on their desktop side, but being slightly embedded focused. At which point, if we're the only people using the developer side, the desktop side, it's our responsibility to make it work. You can't expect somebody who doesn't gain anything to do the work. We're the people who gain from a lot of these desktop features. It's our responsibility. And I do want to say the Qt maintainers, both Jonas, Esko, and Paul, have been absolutely amazing at welcoming people. So what are the next steps in Qt Wayland? Well, we want to explore a couple more API for your Wayland specifics, going really low level and exporting everything that you can do in Wayland to a client. And getting things into Qt Wayland is a very good way of avoiding some of the issues that we might see with dependencies. If we do things on the KDE side, we might hit some challenges. So I mentioned earlier about layer shell. We might want to, well, we do want to expose all of that inside Qt. It's window activation that we've done and have currently exposed as KDE API. We want to just add that QString overload somewhere into Qt, either in Qt Wayland itself or maybe into Qt core so we can use it. And anything that we can't abstract into Qt window, ideally we want to try and expose as much as possible in Qt Wayland API. There is a BOF this week. It is on Tuesday. I can tell you time in my time zone. It's 1 o'clock. For other people, adjust accordingly. Please do attend. There are multiple ways to extend Qt Wayland. If Qt Wayland doesn't have everything you need, so Qt Wayland will do everything like showing a window, but if you want to introduce some custom Wayland protocol, we have some slightly fragmented landscape in KDE. So there's a library called KWayland, which is a very low-level API exposing a one-to-one mapping of Wayland protocols. In general, we found this isn't necessarily a direction we want, because from a client API point of view, it sucks to use a one-to-one mapping with what gets sent over a wire. On Wayland, if you want to send a large struct, we don't send a large struct because of the message as a maximum message size. So instead we send it as a stream where we send each thing individually and then there's a semaphore. And you don't need to know from a client point of view about all of those details. So I think we're finding we want to provide much higher level API and in the right place. But it's also worth mentioning Qt provides a mechanism to extend with custom Wayland protocols. It's a class called Wayland client extension. And we're kind of in a transitional phase of what we're using inside KDE. You can use a mix and match. So to use Wayland client extension, it's very much like using QDBus XML to CPP. It creates a class, it's got virtuals for messages that come to us, and it has methods for things that we send to a compositor. And because everyone just likes to copy existing code, copy a code inside KGUI add-on source recorder, and then just adjust accordingly. It should be fairly intuitive. But what about missing functionality? For example, if you've got an application with toolbars and toolbars sometimes behave a bit differently, how would we expose? And we find the Wayland spec protocol doesn't have what we want. But it's important to know the Wayland specs are still evolving. We are still getting changes in. The activation that we talked about only landed in the last 2 months, and we helped push for that on the KDE side, especially Alice Pohl did a lot of the work. So everything is still evolving. And one of the things that I think has been a problem with Wayland till now is that all the specifications are being decided upon by compositor developers. It's a big group of people, all from different teams, but everyone is a compositor developer. And I think this is the root of a lot of the problems, is this comes with an inherent bias at people answering the questions, what is going to be best from the point of view of a compositor. And we do need a healthy balance. So I think we do need application developers to be coming in saying, well, these are my requirements, this is what I need, please make something that works. So the solution to this is to get involved. Make sure all problems are known and elevated throughout the stack. If you're missing something in Qt, elevate it to Qt. If Qt is missing something in the Wayland protocols, elevate it to Wayland protocols. All the people are very friendly and will listen, as long as they're aware. And a common theme that we've found when we've been doing all of our work is it's better to start ages ago. With all of these things, we thought, oh, I wish I'd done that 5 years ago so I could be using that now. Whether it's a Qt change that we're now blocked on Qt 6, or Wayland protocols, which is a very slow-moving process, for good reason, but it's a slow-moving process. So it's important to just start now. So to wrap this up, test, test, test again. As developers, you should be using Wayland on your application for as much as possible. Even if you don't try and insist that your users use it because of issues, as developers, you really should. And we're here to help. If you have a specific issue, we are happy to help. Please do ping us. If you're on Bugzilla, use a Wayland keyword and it will get noticed by people who search for that keyword, which I do. Don't just move things to Quinn, but add this Wayland keyword so we can keep track of everything. And if need be, elevate issues to Qt. And I think that's the end of my talk. Well, I know that's the end of my talk. I wrote it, and it says the end.
Thank you, Dave. There is first one question. Does the layer shell work on X11, or does it need to be if-deft?
It would not work. It would be possible to write a library that semantically does it in process and have a client only speak in semantic terms, which then get mapped to X11. The layer shell library as is, I don't know if it crashes if you try and use it, but it certainly wouldn't be very useful.
Okay. I'll put in a question. Since you mentioned that Wayland protocols are moving target, how much effort do you estimate has been, let's say, wasted because of those changes?
too much, but a lot is necessary. I think everyone's quite hesitant on committing to API, particularly as Wayland doesn't have a very good mechanism of doing binary incompatible changes. It's got a very good mechanism for adding API, like a binary compatible change, but it doesn't have a very good one for incompatible ones. So people are naturally cautious, like you would be for a public API or a library. But that means people tend to put things in with certain names, and just renaming a protocol with no actual code changes is quite difficult, because you need to support anyone in the old name and anyone using a new name, even if it's the exact same thing across the wire, because this text description of the interface name is sent at some point, and the code generators just don't handle that very well. So,
Okay. Thank you.
Too much, but it's necessary.
Thanks. There are no more questions as far as I can see, but a lot of applause in the chat. So I don't need to say give a hand to David. Thank you for the talk, and see you later.
Bye-bye.
The next talk will start in 3 minutes. Hi, everybody, and welcome back. The next talk will be quite hardcore. It will be by Alex, our memory tagging extension, fighting memory unsafety with hardware. Awesome. So give a warm welcome to Alex. Go.
Yeah, thank you, everyone. Thank you, Ivan, for the introduction. Let me just see. So today my talk is on the R memory tagging extension, of course. So my name's Alex. I've been a developer for about 2 years, I think now, working mostly on KFUs. But this talk is quite different. Something I've been working on recently and studying, and I thought it might be interesting for the rest of you as well in the KD community. Just one quick thing: I don't think I have control of the stuff in the presentation, so I don't think I can change the slides at the moment.
Let me check. Sorry.
Perfect. Okay, we're back in.
Okay.
Okay, so on to the next slide. So before we go into the R memory tagging extension full on, I want to go into the motivation behind this, or why would we need this new hardware feature. So the reason why we need it is because we use C and C++. And when you use C and C++, it is a memory unsafe language. And it has positives, but it also has negatives. So first of all, what does it mean for a language to be memory unsafe? Well, first and foremost, you have access to pointers and you're able to manipulate them as you wish. You're able to do arbitrary pointer arithmetic, not just indexing to an array, but a lot more. Pretty much anything goes, as long as you do it correctly. And this provides some advantages. So, you manage memory by yourself. You decide when you allocate from the heap, when you deallocate from the heap, and this can be quite useful if you don't want to use like a language that has automatic memory management. So Java has a garbage collector that you can use, Python similarly. And in many cases, you do want fine-grained control. So for example, if you're writing a game, you might know beforehand how much memory you need. And dynamically allocating memory can sometimes, especially in games, can be performance insensitive. So if you know how much memory you need, you can just allocate it in one chunk, ready to go. Once the round is over, for example, you beat the boss, you can deallocate all the memory and go to the next one. But there's no such thing as a free lunch. So what do I mean by this? Well, managing memory yourself is hard. You have to think about the lifetime of your memory, who owns this memory, when should it be freed, who's responsible for freeing it, and the techniques to solve it. And a lot of the time we do it correctly, but a lot of the time we don't, and this is where the real stinger comes in. So if you do it incorrectly, you invoke undefined behavior. Once you do something incorrectly related to memory, for example, double free, well, I'll go into it into more detail, you've invoked undefined behavior. So, but what does that mean? Well, let's define undefined behavior first. So I'll read out the definition straight from the standard. Undefined behavior is behavior upon use of a non-portable or erroneous program construct or of erroneous data for which this international standard imposes no requirements. What does this mean? A person implementing the language has no requirement. They don't have to do anything in response to this behavior. So they could ignore it. They could, print something out if they wanted to. No one could complain, really. They just point to the standard and be like, okay, that's not my problem anymore. And so, what a user, for example, might commonly see a segmentation fault, might experience some logical bug. It just might be crazy. Who knows? So why have we allowed undefined behavior to be a thing? Why don't we define the behavior? Why don't we do something like in Java, where if there's an off by one error, we just raise a array index out of bounds exception, for example? Well, these checks aren't free. They have a runtime cost, which you might not want to pay in certain scenarios. The compiler writer also would like an easier time. I mean, C++ is hard enough to implement as it is. and thinking about runtime checks, can be annoying. Also, assuming a program doesn't have undefined behavior allows you to do some optimizations, which again, if a program does have undefined behavior, can result in some weirdly generated code. So, you might get some memory safety bugs. Are they common? Is it even a problem? Can we just shrug it off? Well, they cause countless bugs. Just from simple crashes to security bugs. So, all the way back into, actually, that slide is wrong. It wasn't 98, it was 1988. So this was more than 30 years ago. The Morris worm, I think it took advantage of a simple buffer overflow and took down large chunks of the internet at the time, which was quite small, but it still managed to cause an estimated $10 million in damage. And Morris, the one who created the worm, was put in prison. So damage can seriously be done. And more recently, we can see, for example, Heartbleed, which in 2014 was an OpenSSL bug. I believe also a simple buffer overflow, very simple to catch. It affected, pretty much half the internet, half of HTTPS sites, which basically rendered them useless because, you could read out private keys. And HTTPS wasn't really a thing until you patched it. And Chromium have done, their research, and, they've looked at their bugs, their serious security bugs, high severity, and 70% of them can be attributed to memory safety problems. So the biggest security bugs fundamentally come because of memory safety. Now, again, another thing is that C and C++ programs are very common. So we can see all these stats here. Apache and Nginx have quite a large share of the web server market. Google Chrome is 64% of the web browser market. Windows, a large chunk of the desktop market. Android similarly. And some of you might notice being like, well, okay, Google Chrome 64%, but I mean, Firefox, Opera, Vivaldi, they're also all pretty much written in C and C++. Why are we singling this out? So you're correct to note that pretty much all critical infrastructure that we use today, from kernels to browsers and stuff like this, are written in C and C++. But what makes it really bad is that a lot of the software has pretty much monopoly status. So if you're looking at a nation-state attacker or just somebody who wants to make money from hacking, finding a vulnerability in Google Chrome, if you can easily exploit it and you can reach 64% of the web browsers or of web users, the math checks out. You want to exploit it. You want to look for these bugs. You don't want to just come across them. You want to hunt for them. So this kind of monopoly status also has a big effect. Well, okay. Well, I mean, I've talked about Google Chrome, Apache, Nginx. Why should KDE care? Well, I mean, a lot of our software is written, on top of the Linux kernel and user space. There's also a lot of user space software that we use, so maybe Wayland is also written in C, stuff like this. And obviously, we write most of our software in C, or in C++, and sometimes in C here and there. And, and our biggest libraries that we use, Qt, again, C++. So, we're also part of this problem, well, experiencing this problem. And, we developers, you bound to deal with crash reports, and a lot of these are probably triaged as very high importance. If I go through Nate's blog, quite a few crashes. So guys, we're not perfect. So we've got a lot of work to do. And, crashes, security bugs, weird behavior caused by memory safety bugs, turns our users away, and we want people to use our software. So before I go further, I want to just kind of refresh ourselves a bit. So this is the virtual address space layout for a single process. So you can see the bottom of the address space is at the bottom of the slide, and at the top of the address space, we have the stack, for example. And the stack starts at the top of the address space and grows downwards, on Linux at least. And at the bottom, you can see the text segment, which is just the instructions of the program you're running. The data is, some initialized data at the beginning of the startup. And the heap is dynamically allocated memory that you can get from, malloc or new, or, make unique, make shared, etc. And the heap similarly grows upwards, starting from lower addresses. And to note that the shared libraries are stuff like, well, for example, Qt is maybe dynamically linked, and so the process will start up and put the shared libraries in the correct space so that you can call into it and it's all good. And knowing that is useful for later, so keep that in mind. The stack is managed by, well, at runtime with instructions. The way the stack is used is managed by the compiler in the code generation, so during compile time. And the way the heap looks is managed by the memory allocator code, so usually glibc, at least on Linux. Okay, so let's look at our first kind of type of memory safety bug that you can run into. So we have a simple function here that's vulnerable to a stack overflow. Why? Well, this function takes in 2 arguments that it doesn't use, but you'll see in the next slide why I wanted to put them there. And we allocate a buffer of 100 bytes. And then we take a user input and put it into this buffer. Now, scanf does not do any bounds checking of the input. It just assumes that you're not going to use it any more than 100 bytes. And that is not an okay assumption, especially if somebody malicious has an opportunity to put some stuff there. So if it is overrun either on purpose or by accident, you have a stack overflow. So what's the problem here? Well, not only can it crash a program, it can also be used as an exploit. So let's get ourselves into the minds of an attacker. So the attacker will want to insert input, sometimes called shellcode, that will allow the attacker to take control of the program, to take control of the execution flow. So what does this mean? Well, let's take a look at at an example stack frame. So we have the local variable buff at the bottom here, near the bottom of the stack. When you fill your data in the buffer, it will kind of climb upwards. So if you fill up the buffer, if you start to overflow the buffer, you're going to overwrite, kind of the bookkeeping needed to actually run your program correctly, to set up the stack frames correctly. So in this case, you might need a say frame pointer if a frame pointer is generated. You'll need a return address to know what function to go back to once you're done in this function. And you also might have some inputs on the stack. Sometimes not, sometimes there is. In this case, I assume it is. So what an attacker will want to do is they'll want to put in code. So the shell code is stuff that they want to execute. And they want to overwrite the return address such that it points back into the shell code. So it points into code that they themselves have inputted. And so the shell code might, for example, if we're exploiting Apache, we might want to open a root shell because Apache commonly runs as root. And we want it to be accessible over the internet. Great. You have a root shell of a server, game over. Well, okay, so you might have noticed something. Well, how do I know exactly where the return address is? Well, sometimes isn't obvious. If you have access to the source code, maybe you could figure it out. You can compile the program, play with it locally. Sometimes you might not be so lucky. So the first question is, do I need to guess exactly where the return address is when I'm designing my shellcode? No. Just write it many times as a suffix if you can, and then one of them will hit. Okay, well, what should my return address be? Well, it should point into the shellcode somewhere, but if we're off by a bit, we might just crash the program. We won't execute the shellcode we want. Well, we're in luck. We can use certain NOP instructions, so no operation, doesn't do anything. And we can prefix our shellcode with it. And then hopefully our return address will pop back in, and it'll hit. If it hits any of the NOP instructions, it's just going to call NOP until it starts into our real shellcode. And then hopefully we're good. Now, obviously, you hope that the buffer is large enough for you to kind of pull this off. So if you've overflowed a 4-byte buffer, I mean, good luck getting any decent amount of shellcode. But if it's bigger, like 100 bytes, you could probably pull something off. And these are quite common because you have access to change the return address. So this has been around for, well, since the inception of C, since the inception of C++. Have we just been sitting there? No. So the first mitigation for this type of potential exploit is write or execute pages. So usually trying to allocate pages, and at the time there was no requirement if you could do write, execute, or read pages. But the question is, why is the stack executable? It shouldn't really be executable. We shouldn't want to execute code that the user has put in. That doesn't really make too much sense. So why don't we establish a requirement and say you can have a page and you can either write to it or you can execute it, but not both. And so how will this stop our previous attack? Well, if the return address leads back into code that we just inputted, we make sure that it's only given write access. So we can only write to this page. And so when we try to execute instructions in that page, we'll generate a fault because we're not allowed to execute that shellcode. Okay, so I mean, are we done here? No. We can work around it. So if we remember earlier, there are some shared libraries that have code, like the C standard library, C++ standard library, maybe Qt, whatever. And so the workaround is, well, why don't we just set the return address to a commonly known function that we might want to use in the C library. So for example, we might call system bin/sh. So we'll set up the return address correctly. We'll set up correctly. We'll put in the argument to the string that we want, or the arguments that we want, and then we'll call it. And then we've got ourselves a root shell again. So while this work, well, libc will be mapped in with execute permissions. So we've just worked around it. Okay, have we just been sitting again? No. So another concept is, or another tool is address space layout randomization, ASLR. The idea is randomize the address space, which means that it's hard to guess, what the location of this libc function is. Because without ASLR, I can just be on my local laptop, have a look what libc is on my local laptop, and I'll probably map to whatever's going on the server, for example. But with ASLR, it'll be random each time. So again, for 32-bit, it doesn't really work out as on-off entropy. You can get around it. There's a paper on it. And it still isn't perfect on 64-bit, but it's still kind of useful to still have, so distributions will still use it. If you're interested to see how to break it on 64-bit, Hacking Blind paper will show you. Although it's kind of complicated, it's a talk in itself. So what you're seeing here is kind of like a cat and mouse game, but we haven't really stopped the problem at its core yet. And maybe we never will. Sorry. Okay, yeah. So, okay, well, that's on the stack, but we can also have heap overflows. So we're going to have two structs here. One just stores a character or an array, and the other has a function pointer. Now we're going to allocate these two on the heap, and maybe they might be basically adjacent to each other. And we're going to assign the function pointer, just to the exit function. But at the same time, we're going to accept a user argument, and we're going to write it into the name array. Now, what could happen here is that if I overwrite it, I might be lucky enough and find that because D and F are adjacent to each other, we hope, I can actually overwrite it such that the function pointer is not exit, but a function of my choice. Again, if I set up the arguments correctly, I could do something similar to, a return to libc attack. Or even to my own shellcode, similarly, again. But the same workarounds apply. Sorry, the same mitigations apply. But as we can see, the heap is still exploitable, despite the fact that the heap doesn't really contain a return address per se. There's only kind of like internal bookkeeping. We've still managed that in this case, we've still managed to find a return address and change the control flow of the program. Again, if write or execute exists, then this doesn't work out straight away. But what I'm trying to illustrate is that you can do on the heap what you could do on the stack, although it is a bit harder. Okay, so so those two, the heap and stack overflows, are kind of what we call spatial memory safety bugs. So those are like when we manage memory incorrectly and stuff starts overwriting each other all the time. But what about temporal memory safety bugs? So this is when we incorrectly manage the lifetime of memory that we allocate. So here's a use after free function. So we declare a pointer to an integer. We allocate some memory to it. We assign it value. We free it, and then assign a value to it again. Now, this example by itself isn't, exploitable. But the vulnerability is that we've used something after we freed it, so we have no claim to this memory, and so this could easily be a crash. Although, again, it's undefined behavior, so it might not crash at all. Okay, so let's imagine a scenario where we could exploit a use after free. So, as in the previous case, we freed the memory, but we still had a dangling pointer to it. So let's assume that the program assumes the data contains a function pointer. So the dangling pointer points to a function pointer. And let's say the attacker is able to input a return address of his choice into a new allocation. So maybe there's a malloc call or a new call later, and the attacker can put in some input. Then if the program uses that dangling pointer and the attacker successfully puts a return address of its choice there, again, you've taken over the control flow. So again, a lot of assumptions here. Is this likely? Well, I mean, yeah. So half of the 70% of high severity bugs can be attributed to use after free. So quite a lot. So it's definitely something we should look out for. I mean, to avoid dangling pointers when programming, please, once you've freed something, set the pointer to null. That will help to prevent this particular scenario here. Again, we can do similar stuff on the stack. So we have a use after return here. So if you see the func function here returns a pointer to an integer. So we allocate one on the stack and return a pointer to it. But obviously, after it's returned, we have no claim to this memory. It's the use after return. And we try to use it in the main function. Again, undefined behavior. We have no claim to that memory anymore. You also have use after scope. So if you're in a scope, the same applies, similar to return. So an attacker can exploit this in the same way as the use after free that we talked about earlier. Now, let's look at some other tools that have been used to help prevent these type of things happening in the first place. So we looked at mitigations already. But let's talk about how can we even prevent these coming into our programs. So we could be in a scenario where we don't even need these mitigations. So again, prevention is better than the cure. So in this section, I'm going to go through some tools and we'll build up to, MTE. Do some mental arithmetic. Okay, the time's good. Okay, right. So let's talk about address sanitizer first. So basically, address sanitizer is some compile instrumentation, and a runtime library, and it detects quite a few of the classes of bugs that we've talked about earlier. It's easy to use. You can use it now in your programs. Please do when you're developing. Luckily, if you use extra CMake modules in the KDE frameworks, as you can see with that line of snippet, you'll get the right compiler and linker flags set up for you. So it's more of a debugging tool, more than a mitigation. But the idea is that it kind of, upon detecting these types of bugs, it will quit the program and give you good debugging information such that you can fix the issue. So how does it work? What does it use? So to detect spatial memory bugs, it uses a concept called the red zone. So each allocation, both on the stack and on the heap, and even in globals, has a red zone on the other side. And basically, it means that if you overflow, for example, by 1, you'll find yourself in the red zone. Finding yourself in the red zone means abort the program, you've done something wrong. So as you can see, there's an overhead there because the red zone stuff is just empty kind of space, basically, designed to catch your mistakes. And to detect temporal memory bugs, so freeing them and using a dangling pointer, we use something called a quarantine around allocations. So basically, it consists of a queue such that when you free, the allocator tries its best not to reallocate that memory very soon. And it keeps track of the fact that that it was freed recently, such that if you do use the dangling pointer again, you will crash. So how is this done? Well, there's something called shadow memory, which you can see a table of here. So it's quite clever. In the compile instrumentation, on every load and store, it does a quick check to see what type of memory is it. So as you can see, memory points to, with a simple offset, you can point to the shadow memory. It's very simple math, basically. Well, I think 1 or 2 instructions. So to keep the overhead low. And the shadow memory stores metadata in 1 byte, talking about 8 bytes of addressable memory. And then it says, well, how much of this memory is addressable? And for the parts that are unaddressable, what type are they? Is it a red zone? Is it a quarantine, etc.? And so using this, it can determine if you've gone into the red zone, if you've gone into something that's in quarantine. So it's quite nifty, quite smart. So it was released probably about 10 years. Well, it was released 10 years ago. And it reduced overheads quite considerably compared to Valgrind. So if you ever use Valgrind, the overhead was quite excessive. People still use Valgrind now. It does detect some things that Assan doesn't. But Assan had much better CPU overhead, 73%, so 10% less. Sorry, not 10%, 10 times less, order of magnitude. And the memory usage increased by 3 times, so quite a lot, but still probably more manageable than Valgrind. And so you could use this easily for debugging for most programs, but production use, probably not. And, Chrome and Mozilla, and I guess us, have had a good time, finding bugs with this. So when they used it, they found 300 bugs in the Chrome codebase in the first 10 months. But it is a dynamic analysis tool. So a static analysis tool just looks at the source code and decides if there's any problems that it knows about. But the dynamic analysis tool only does its work when it's running. And so, your analysis is only good as the test suite you're using. No tests, Assan is effectively useless. But recently, we've seen the trend of fuzzing. KDE does use fuzzing. I think somebody's manager, I think it's Albert, who manages OSSS fuzz, which uses Assan. So fuzzing is basically just using random inputs. And if it crashes, it's like, okay, I'll try more inputs that are like this. That's a whole field in itself. But Assan and fuzzing are amazing tool. Okay, so what's the next iteration? What are we going for next? So now we have hardware address sanitizer. So that consists of compiler instrumentation and a runtime library, similar to Assan. And it detects a similar class of bugs to Assan, but it uses a completely different technique of doing its work. So firstly, it relies on a feature called ARM-TBI to store something called tags. And the technique it uses is called memory tagging. So I'll talk about that more in a moment. Again, pretty much as easy to use as Assan. Just provide the correct compiler flags. We don't support an extra CMake modules yet, I believe. Correct me if I'm wrong. It's only supported in Clang, I think, as well. And only supported in ARM for now. Intel is releasing something called linear address masking, which might mean Assan might actually work on Intel soon. So keep your eyes peeled. Okay, so I mentioned ARM-TBI, but what is it? So registers, at least on ARC64, are 64 bits wide, but virtual addresses are only 48 bits. So there's only 48 bits of addressable memory, or 2 to the 48 bits. And so the other 16 bits are just set to 0 or all ones, and it has to be that, otherwise, bad times for you. But ARM-TBI is a new feature, well, not new, but a hardware feature that relaxes this requirement. And so in that top byte, you can store any value that you want. So just the 8 bytes, just the byte. The other byte under it still has to have a certain value, but this top byte, you can put any value you want. And so in this case, Assan will use it to store a tag associated with a pointer. Now, some of you may have thought, but is this a good idea? Like, is it always the case that we're not going to use all 64 bits? I mean, Intel is going to introduce, or might have already introduced, 5-level paging, which means that they've opened the fact that we might have a 2 to the 57-bit address space. So could it be 64 soon? Could this not work out? I'll leave it to you to think about that. So let's talk about the concept of memory tagging. It's a general concept. It's not related to ARMMT by itself. You can just think of it independently of the hardware. So let's first define 2 keywords before we carry on. So first we have the tagging granularity, the amount of memory associated with any given tag, so 16 bytes for Hwasan. And then we have the tagging size. So it's the possible size of a given tag. How many tag values are there? So if it's 1 byte, you can have 256 different tag values. And so each granule of memory is associated with a tag, and then all pointers to that same location memory should have the same tag. And so upon each memory access, you want to make sure that you compare the tag of the pointer with the tag of the memory it points to. And if they don't match, you abort. You say there's an issue. Okay, so that's quite general. Why for memory safety? Well, it uses compiler instrumentation and the runtime library, and it uses this concept to basically do its magic. So what does it do? So the memory allocator is modified to do the heap tagging. So on allocation, you have to align to the tagging granularity. And you randomly assign a tag to the memory and the pointer, and they should be the same. On deallocation, so on 3, for example, you assign a new random tag to memory. So why does this work? Well, it works because, let's say you allocate a value x, and then so if you're preventing use after 3, if you deallocate and get a new value, chances are it's not going to be x, it's going to be some other value y. So if you use that pointer again, if you use that dangling pointer again, there's going to be a tag mismatch. Similarly, for a series of allocations, they're likely, because they're independent, to have different tags. And so if you overflow into a different allocation, they're likely to have different tags. You still have a 1/256 probability of missing some. So sometimes they might match when they shouldn't. But I mean, this is more than 99%, so this is pretty good. The compiler also needs to be changed. So all local variables need to be aligned to the tagging granularity. And again, you assign a tag to the memory and pointer. So instead of deallocation, you change the tag again on function exit. So when you get rid of the stack frame. For the stack, a single base tag is used, and all other tags are derived from it. So basically, it's a bit too expensive to do a separate allocation, to generate a random tag for each allocation on the stack. So you just use a base tag, and then you might increment on top of it and just go in circles, for example. So add 1 to the next allocation, add 2 to the next allocation, and stuff like that. Okay, so is it better than ASAN? Well, it has a smaller RAM overhead because you don't need a red zone, you don't need quarantine. You just need the storage for the tags itself, and you need to align both the stack and heap variables. It's also better at detecting non-adjacent out-of-bounds access. So the Renzo doesn't really help you if the access is not adjacent, if it's like all over the place. It's also better at detecting use after 3 over time, again, because the quarantine is only good as the size of the queue. But ASAN still does have some kind of advantages. So the bug detection is deterministic for ASAN, but Hwasan still has a chance to miss it, even though it had, there's 1/256 probability of missing it. Also, because of the granule, if you, for example, have an 8-byte allocation and you overflow 12 bytes, it's going to look like it's the same tag, or they will have the same tag, and so you won't catch that. Okay, so let's motivate ARMMTE. So ARMMTE is a new hardware feature. It's not available yet, but it's available on Chemi if you want to play around with it. So it's an implementation of the memory tagging concept with the same tagging granularity of 16 bytes, but the tagging size is 4 bits, so it's less than Hwasan. Again, it uses ARM-TBI to stick it in to give space for a tag and a pointer. The mapping of granules to tag values is stored in main memory, so it's reserved at boot. So this is memory that you can't use it for any other purpose after it's booted. So that's roughly 3% of your memory gone. So keep that in mind. That's a cost. That's an overhead. There's also some instructions to generate, manipulate, and view tags. And there's two modes of usage. So assuming you've mapped the memory with MT enabled, so there's a flag for that. You don't have to think about it as application user. But there's two types. There's synchronous, so a tag is checked on each load and store instruction straight away, and the segmentation fault is generated with a faulting address. This is slower, but again, you get more useful information for debugging. But asynchronous tag checking is delayed until the next context switch. So a segmentation fault is generated without a faulting address. So it's quicker, so it might be good as a mitigation for these types of bugs, but it's not good for debugging. Okay, so you can have, so again, heap tagging, there's an implementation for glibc. A certain tag is reserved for internal data structures like bookkeeping and headers and stuff like that. But fortunately, the tagging granularity is the same. So heap tagging doesn't have much of an alignment issue. Again, a similar algorithm to Hwasan. But to note here, the difference is that calloc is actually no more expensive than malloc because there's a special instruction to set the value to 0. So it doesn't cost anything extra. And realloc always retags, no matter if you have to move the memory or if it doesn't move, you always just retag. So that's useful. Stack tagging is done with Clang, so as an implementation for that.
Sorry for interrupting you, Alex. You have 3 minutes left.
Okay. So again, similarly to Hwasan, there's some stack tagging. It's implemented as a simple function pass, but the alignment is much of a bigger problem there. So you need to do a 60-line alignment, and that can be quite annoying. But stack safety analysis can be used to it's basically a tool that decides if there's a chance of memory safety issues occurring. If there's no chance of this occurring in a function or a scope, just don't bother tagging it, and you'll be fine. So that can help reduce the code size overhead and just the runtime overhead. So here's an example. I think I'm gonna have to skip over this just to the time issues. But you can see there's some extra instructions there. But what ARM-MTE offers is it should offer smaller CPU overhead because you don't need to do compiler instrumentation for each access. That's handled in the hardware for you. Obviously, the hardware isn't released yet, so we don't know what that is. But hopefully, it's quite low. The RAM overhead is also kind of a tiny bit smaller. You can't really see it in user space, but there is storage. So there's 3% already gone, and then there's like the alignment that you need to deal with as well. The code size also should be smaller because you don't need the compiler instrument or a lot of the compiler instrumentation. And from my measurements, it's less than 5% as claimed. And for heap tagging, a good thing is that you don't need to recompile programs. So long as you've got glibc, you're in good shape. Hwasan is still better because the tagging size is bigger. So with only 4 bits, then we still have a 7% chance of missing out on the bug. So that can be a big issue. So there are some unconventional use cases. There's only 1 minute left, so I can't really talk much about it. But I think the slides are clear just from reading it. So I'm going to leave it to half a minute of questions, I think, unfortunately. I wanted to go for these slides, but I think I can. Are there any questions?
Okay, first, thank you for the awesome talk. I would really advise you to split it into 3 talks for the next Academy. So, okay, because this is something that we should all learn and I guess know by heart. A question that I would like to ask, so most of these tools are something that mitigates already made bugs or detects the already made bugs. Do you see a world where we could avoid making those bugs in the first place? Obviously.
I think the world is always trade-offs, right? So in many cases, we can avoid quite a lot of them by using just a different language. The real question is, can we do it? Can we have it like a free lunch? So I guess we've seen with Rust there's some improvement in certain areas. But again, not a free lunch. It's in some ways a harder language. Mm-hmm. So I don't think we'll kind of reach that kind of 100% stage. But hopefully the trade-offs will fall more in our favor over time. So I think ARMMT is one of those, for example.
Cool. I think that's all the time that we have. Thank you yet again, and enjoy all the claps in the chat. People are clapping. I'm not going to count all the claps that you got.
Okay, thank you.
So thank you yet again.
Yep. Yeah, but if any questions, feel free to email me, or just I'm commonly in. My nickname is Feverfew, so any have questions, please let me know. Yeah, thank you.
Cheers.